There are places in our oceans that challenge everything we thought we knew about the natural world. Mysterious formations lurking beneath the waves that no scientist can explain. Massive walls of water that appear without warning, defying the physics we've established. Fleeting optical phenomena that have puzzled sailors for centuries. Strange sounds echoing through the depths that have no identifiable source. These aren't tall tales from superstitious mariners or internet speculation. These are documented phenomena that marine biologists, oceanographers, and physicists continue to study without reaching definitive conclusions. From an unusual disc-shaped object on the Baltic seafloor that interferes with electronic equipment to waves so enormous they were considered mathematically impossible, until recently. Tonight we're exploring unexplained ocean phenomena that simply cannot be ignored. Evidence that challenges our understanding of the world's most mysterious realm and reminds us just how little we truly know about the vast waters covering 70% of our planet. Before we dive into these depths, here's a quick note. The visuals in this video aren't necessary to enjoy the stories. They make it more dynamic, but you can keep up with the stories strictly through the audio. Feel free to let this play in the background while you work, relax, or even fall asleep to these perplexing mysteries. And if you'd like to support me making these videos, consider subscribing to the channel. So sit back, relax, grab a snack, and let's begin our journey through the most baffling mysteries hidden beneath the ocean's surface. Beneath the cold waters of the Baltic Sea lies something that has challenged our understanding of what exists in the unexplored depths of our oceans. In the summer of 2011, a Swedish diving team called Ocean X was scanning the seafloor between Sweden and Finland. They were treasure hunters at heart, searching for old shipwrecks that might contain valuable artifacts or historical treasures. But what they found that day was something far stranger than any sunken galleon or merchant vessel, something that would spark worldwide debate and challenge the boundary between science and science fiction. The sonar images revealed an unusual circular formation about 290 feet below the surface. At first glance, it appeared almost manufactured, a perfect circle approximately 60 feet in diameter with what looked like straight edges, right angles, and geometric patterns. The divers called it the Anomaly, and as images began to circulate online, theories about what this mysterious object could be spread like wildfire across the internet. When the Ocean X team finally managed to dive down and examine the anomaly up close, what they reported only deepened the mystery. According to the team's co-founder Peter Lindbergh, they found what appeared to be a massive disc-shaped object with features that seemed almost designed. Strange rock formations created what looked like corridors and stairways. Peculiar stone circles dotted the surface like some kind of ancient control panels. Perhaps most intriguing were the reports of a smooth, almost polished appearance to parts of the structure, as if it had been manufactured rather than formed naturally. But the strangeness didn't end there. The team reported equipment malfunctions whenever they got close to the anomaly. Electrical devices would mysteriously stop working within a certain radius, only to function normally again when moved away from the site. Their satellite phone reportedly wouldn't work when directly above the anomaly, and camera equipment suffered unexplained failures. It was as if the object was generating some kind of electromagnetic field that interfered with modern technology. Samples brought up from the site added yet another layer to the mystery. Analysis revealed unusual metal compositions, high levels of limonite and goethite. Some researchers noted that these metals don't typically occur naturally in such concentrations in that part of the Baltic. And then there were the perfectly straight lines and 90-degree angles that seemed to defy natural geological processes. Nature, after all, tends to favor curves and irregular shapes over the precision of right angles. So what exactly is the Baltic Sea anomaly? The theories range from the scientific to the sensational, each with their own evidence and counterarguments that make this underwater mystery so compelling. The most dramatic theory, and the one that captured public imagination, is that the anomaly is actually a crashed UFO, an extraterrestrial craft that sank to the bottom of the Baltic Sea thousands or perhaps millions of years ago. Supporters of this theory point to the disk shape, the geometric patterns, the equipment malfunctions, and the unusual metal composition as evidence that this is technology not of this Earth. Some have even drawn comparisons between the sonar image of the anomaly and the fictional starship Millennium Falcon from Star Wars, noting the similar disk shape and apparent structural features. But scientists and geologists have offered more earthly explanations. Some suggest that the anomaly could be a glacial deposit, a massive rock or collection of rocks transported and shaped by moving ice during the last ice age, approximately 12,000 years ago. The Baltic region was heavily glaciated during this period, and glaciers are known to move and deposit enormous boulders and rock formations, sometimes creating unusual shapes and patterns in the process. Others propose that it might be a natural geological formation, perhaps a volcanic remnant or an unusual type of rock outcropping. The straight lines and geometric patterns could be the result of natural fracturing, as certain types of rock naturally break along straight lines and at consistent angles. The basalt columns of the Giant's Causeway in Ireland are a famous example of how nature can sometimes create seemingly artificial-looking geometric patterns. There's also the possibility that the anomaly is indeed man-made, but of human origin, perhaps the remains of a sunken Nazi anti-submarine device from World War II, or an old concrete foundation for a now-vanished structure. The Baltic Sea has a long history of naval warfare and human activity, and many artificial structures have found their way to its bottom over the centuries. But none of these explanations seem to perfectly account for all the reported features of the anomaly. The equipment malfunctions, if accurately reported, are particularly difficult to explain through natural geological processes. And while glaciers can certainly transport and deposit large rocks, the specific shape and reported features of the anomaly remain unusual even by glacial standards. Adding to the challenge of solving this mystery is the difficulty in conducting proper scientific investigation at the site. The Baltic Sea anomaly lies at a significant depth, making diving operations expensive and complicated. The visibility in the Baltic is often poor, and the cold temperatures make extended examination difficult. And then there's the matter of funding. Scientific expeditions are costly, and without concrete evidence of something truly anomalous, it's been difficult to secure the resources needed for a thorough investigation. What makes the Baltic Sea anomaly such an enduring mystery is this gap between the initial reports and the scientific follow-up. We have intriguing sonar images, we have the testimonies of the divers who visited the site, but we lack the kind of comprehensive scientific data that would definitively identify what this object really is. This information vacuum has allowed theories to flourish, from the mundane to the extraordinary. Perhaps the most interesting aspect of the Baltic Sea anomaly isn't what it might be, but what it reveals about our relationship with the unknown. We live in an age where it feels like every corner of our planet has been explored, mapped, and explained. And yet here, in the relatively shallow waters of the Baltic Sea, just a few hundred feet down, lies something that continues to defy easy explanation, a reminder that our world still holds mysteries, even in places we thought we understood. When we look at the sonar images of the anomaly, we're not just seeing an unusual seafloor formation, we're seeing a mirror that reflects our own expectations and desires. Those who yearn for evidence of extraterrestrial contact see a crashed spaceship. Those with a geological mindset see unusual but natural rock formations. We project our hopes and fears onto the blank canvas of the unknown. And that's what makes ocean mysteries like the Baltic Sea anomaly so captivating. The oceans cover more than 70% of our planet's surface, and we've explored less than 5% of their depths. The Baltic anomaly serves as a humbling reminder that even in relatively accessible waters, there are things we don't yet understand. phenomena that challenge our assumptions and ignite our imagination. Until a fully funded scientific expedition can properly document, sample, and analyze the anomaly, it will remain in this liminal space between the known and the unknown. For now, it exists as a question mark on the seabed, a 60-foot-wide riddle that continues to invite speculation and wonder. Whether natural formation or something more extraordinary, the Baltic Sea anomaly reminds us that our world is still filled with mysteries waiting to be solved. What else might be hiding in the unexplored regions of our oceans? What other anomalies lie waiting for discovery in the murky depths? The Baltic Sea anomaly may be just one of many strange formations and unexplained phenomena that exist beneath the waves, challenging our understanding of the world around us and reminding us that the era of discovery is far from over. But not all ocean mysteries remain fixed in place like the Baltic Sea anomaly. Some appear without warning, towering above ships before vanishing back into the sea. Destructive forces of nature that sailors have feared for centuries, but scientists have only recently begun to understand. These are the rogue waves, massive walls of water that seem to defy the normal physics of the ocean, appearing out of nowhere to wreak havoc before disappearing just as mysteriously. For centuries, sailors returned from voyages with terrifying tales of enormous waves that appeared without warning, towering above their ships like watery mountains before crashing down with devastating force. These stories were often dismissed as maritime folklore or exaggerations from traumatized survivors. After all, how could a wave twice or three times the size of its neighbors suddenly materialize in otherwise normal sea conditions? It seemed to defy the basic principles of ocean physics. But on January 1st, 1995, science finally caught up with sailors' stories. It was New Year's Day at the Draupner oil platform in the North Sea off the coast of Norway. The weather was rough but not extraordinary for the North Sea in winter, with waves averaging around 20 to 30 feet high. The platform was built to withstand such conditions until something unprecedented appeared on the horizon. Instruments on the platform recorded a single massive wave measuring 84 feet in height, nearly the height of an 8-story building, that slammed into the platform before disappearing back into the ocean. This wasn't just any large wave. It was significantly taller and steeper than the surrounding waves, appearing suddenly as if from nowhere. Most importantly, it was measured by scientific instruments, making it the first confirmed rogue wave in history. The Draupner wave, as it came to be known, forced oceanographers to reconsider what they thought they knew about wave formation and behavior. Suddenly, the maritime tales that had been dismissed for generations gained scientific credibility. Rogue waves were real, and they were even more terrifying than the legends suggested. But what exactly are rogue waves, and what causes them to form? By definition, a rogue wave is one that is more than twice the height of the significant wave height in a given area. The significant wave height is the average height of the largest one-third of waves in a wave record. This means that in seas with average wave heights of 30 feet, a rogue wave would need to be over 60 feet tall, and many have been recorded at much greater heights. What makes these waves particularly dangerous is not just their size, but their unpredictability and unusual shape. Unlike normal waves that gradually build and crest, rogue waves often have extremely steep faces, almost like moving walls of water, with deep troughs before them, sometimes described as holes in the sea. Ships encountering such waves can find themselves climbing a near-vertical face of water before plunging into a trough, so deep it seems as though the ocean has opened up beneath them. For centuries, these waves were considered so unlikely that they were statistically classified as once-in-10,000 years events. But modern observations have revealed that they occur far more frequently than previously thought. Studies using satellite data suggest that at any given moment, there are at least 10 rogue waves in the world's oceans. This revelation has forced scientists to develop new mathematical models and theories to explain how these monster waves form. One leading theory involves a phenomenon called constructive interference, where multiple wave trains traveling at different speeds and directions converge at a single point. When the peaks of these different wave systems align perfectly, they combine to create a wave much larger than any individual component wave. It's similar to when two ripples meet in a pond and momentarily form a higher peak where they intersect. Another theory focuses on a process called nonlinear focusing, where energy from smaller surrounding waves is transferred to a single wave through complex interactions. This can occur when fast-moving waves catch up to slower ones, concentrating energy into a rapidly growing wave. Some researchers believe that certain ocean currents, particularly when flowing against the direction of the waves, can also contribute to rogue wave formation by compressing wave energy into smaller areas. The Agulhas current off the coast of South Africa is notorious for creating conditions favorable to rogue waves. Here, the current flows directly against the prevailing wind direction, creating a natural laboratory for rogue wave formation. It's no coincidence that this region, particularly the area near the southern tip of Africa once known as the Cape of Good Hope, was historically renamed the Cape of Storms by sailors who experienced its deadly wave conditions. What makes rogue waves particularly insidious is that they can occur in otherwise moderate sea conditions. Unlike tsunamis, which are caused by underwater earthquakes or landslides and affect entire coastlines, rogue waves can materialize in otherwise normal ocean conditions, strike a single vessel, and then disappear without a trace. A ship could be sailing in manageable 20-foot seas when suddenly a 60-foot monster rises before them, giving the crew mere moments to react. The destructive power of these waves is difficult to overstate. When a rogue wave strikes a ship, it can exert forces far beyond what the vessel was designed to withstand. Modern cargo ships and cruise liners are typically built to endure waves up to 45 feet high, but rogue waves can far exceed this limit. The impact can shatter windows on the bridge, flood engine rooms, damage cargo, and in the worst cases, break ships in half or capsize them entirely. The cruise ship MS Bremen encountered a 100-foot rogue wave in the South Atlantic in 2001. The wave smashed through the bridge windows, short-circuited all the electronics, and left the ship temporarily without navigation or propulsion systems. Remarkably, the ship survived, but the incident highlighted how even modern vessels are vulnerable to these ocean anomalies. Perhaps the most famous suspected rogue wave incident involved the SS Edmund Fitzgerald, a massive Great Lakes freighter that sank suddenly in Lake Superior in 1975, taking all 29 crew members with it. While the exact cause remains debated, many experts believe the ship may have been hit by a series of rogue waves, causing catastrophic damage and leading to its rapid sinking. That such waves could form even on lakes, though rare, demonstrates the widespread nature of this phenomenon. The mystery of rogue waves extends beyond their formation to their prediction, or rather, the current impossibility of predicting them. Despite advances in wave modeling and oceanography, we still cannot forecast when and where a rogue wave will appear with any useful accuracy. Sailors and ships venturing into the open ocean do so with the knowledge that at any moment, without warning, they could face a wall of water capable of overwhelming even the largest vessels. This unpredictability adds to the mystique and terror surrounding rogue waves. They represent a reminder that for all our technological advances and scientific understanding, the ocean remains a place of profound mystery and danger. We can launch spacecraft to distant planets with pinpoint accuracy, but we cannot tell a captain when a rogue wave might appear on the horizon of tomorrow's voyage. Modern research continues to improve our understanding of these phenomena. Wave tanks in laboratories now attempt to recreate rogue waves under controlled conditions, while advanced computer models simulate the complex interactions that might lead to their formation. Satellite technology allows researchers to scan vast areas of ocean surface, identifying and measuring unusually large waves from space. Yet despite these advances, rogue waves maintain their aura of mystery. Like many ocean phenomena, They exist at the intersection of known science and the unknown, a reminder that our planet's waters still hold secrets and dangers that we are only beginning to comprehend. The sailors' tales that were once dismissed as superstition have been validated by science, but the complete understanding of these monster waves remains just beyond our grasp. What other maritime legends might eventually be proven true by science? What other mysteries lie beneath the surface of our world's oceans, waiting to be discovered or explained? As we continue to study phenomena like rogue waves, we come to appreciate that the line between myth and reality is often blurrier than we might like to admit, especially when it comes to the vast, mysterious realm of the open ocean. But not all ocean mysteries are as terrifying as monster waves from nowhere. Some are beautiful, fleeting moments of wonder, rare displays of natural magic that have captivated sailors, scientists, and beachgoers for centuries. Among these magical ocean phenomena is a brief flash of colored light that appears just as the sun touches the horizon, a phenomenon so quick and so rare that many doubt its existence until they've seen it with their own eyes. Just as the last sliver of the sun dips below the horizon, a brief flash of emerald green light appears, so quick you might doubt you saw it at all. This is the legendary green flash, a rare optical phenomenon that has captivated observers for centuries. It happens in that fleeting moment when the sun meets the horizon, a split second of brilliant color that seems to defy explanation. Jules Verne wrote about it in his 1882 novel, The Green Ray, claiming that those who witnessed it would gain extraordinary insight into their own hearts and the hearts of others. While Verne's mystical properties might be fictional, the green flash itself is very real, though no less magical for being explained by science. The green flash isn't a myth or a legend. It's a documented atmospheric phenomenon that occurs under specific conditions. Yet it remains mysterious simply because it's so difficult to observe. It lasts only a second or two at most, sometimes just a fraction of a second, and requires near-perfect conditions to be visible. Many lifelong ocean dwellers and sailors have never seen it, while others have been fortunate enough to witness it multiple times. This elusiveness has contributed to its almost mythical status in maritime culture. To understand the green flash, we need to understand how light travels through our atmosphere. Sunlight, which appears white to our eyes, is actually composed of all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. When sunlight enters our atmosphere, it encounters air molecules and particles that scatter and refract the light. Different colors of light have different wavelengths, and these wavelengths interact differently with the atmosphere. Blue light has shorter wavelengths and scatters more easily, which is why the sky appears blue during the day. Red and orange light have longer wavelengths and can travel more directly through the atmosphere. When the sun is high in the sky, we see it as white or yellow because all the wavelengths of light reach our eyes together. But when the sun is at the horizon, its light must travel through much more of the atmosphere to reach us, nearly 1,000 miles of air instead of just the 100 or so miles when it's overhead. This longer path means more scattering and refraction of the light. As the sun sets, the red, orange, and yellow wavelengths can pass more easily through this thick layer of atmosphere, which is why sunsets typically appear in these warm colors. Blue and violet light are scattered away almost entirely, but something interesting happens with the green light. It's scattered less than blue, but more than red. Under the right conditions, there's a moment when the red and yellow light has been refracted away from our line of sight. The blue has been scattered out of the picture, but the green light is still visible for a brief moment before it too disappears. This creates the famous green flash. The effect is enhanced by atmospheric refraction, the bending of light as it passes through air layers of different temperatures and densities. This refraction actually allows us to see the sun for a few minutes after it has geometrically passed below the horizon. The atmosphere acts like a prism, separating the colors of sunlight and creating the conditions for the green flash. But not all green flashes are created equal. Scientists have identified several different types of this phenomenon, each created by slightly different atmospheric conditions. The most common is the flash, a brief burst of green light just as the upper rim of the sun disappears below the horizon. There's also the green ray, a beam of green light that shoots up from the sunset point, and the rarer green rim, where the entire upper edge of the sun turns green for a few seconds before setting. The ideal conditions for observing the green flash include a clear, unobstructed view of the horizon, typically over water where the horizon line is more defined. The atmosphere must be clear, with minimal haze, dust, or pollution. Temperature differences between the air and water surface can enhance the effect, which is why green flashes are often more visible in locations where warm air flows over cool water or vice versa. Some locations around the world are known for more frequent green flash sightings. The waters off Hawaii and California often provide excellent viewing conditions, as do certain parts of the Mediterranean Sea where clear skies and stable atmospheric conditions prevail. The polar regions, particularly Antarctica, also offer good opportunities due to their clean air and the way the sun skims along the horizon during certain seasons rather than setting vertically. Despite knowing the science behind the green flash, witnessing one remains a special experience, a moment when the mechanical movements of our solar system and the physics of light combine to create something that feels almost magical in its beauty and brevity. The flash has been the subject of superstitions and folklore in many maritime cultures. Some traditions hold that seeing the green flash brings good luck or marks a day of significant change. Others suggest it enhances one's ability to read others' thoughts, an idea perhaps borrowed from Jules Verne's novel. What makes the green flash particularly interesting is that it exists at the intersection of the explainable and the mysterious. We understand the physics behind it perfectly well, and yet it retains an element of unpredictability and wonder. You can go to the perfect location, under seemingly ideal conditions, and still miss it completely. Or you might glimpse it unexpectedly on an ordinary evening at the beach. This capriciousness gives the green flash a certain personality, as if it chooses when to reveal itself. The phenomenon isn't limited to sunsets, either. The same effect can occur at sunrise, though fewer people tend to be watching the horizon at dawn. In theory, the green flash could even be observed from the edge of any planet with a suitable atmosphere. A Martian green flash would look different from Earth's due to the different atmospheric composition. Modern photography has made capturing the green flash easier, with high-speed cameras able to freeze the moment in time. Yet photographs rarely convey the full experience. The sudden appearance of emerald light, the way it seems to linger in your vision even after it's gone, the feeling of having witnessed something rare and precious. It remains one of those natural phenomena that is best experienced firsthand. Perhaps what makes the green flash so appealing is that, unlike many ocean mysteries, it exists right at the boundary between the everyday world and the extraordinary. It doesn't require venturing into the deep abyss or facing monstrous waves. It asks only for patience, clear skies, and an attentive eye. It's a reminder that even in our thoroughly mapped and explained world, moments of natural magic still occur daily, if we only know where and when to look. The green flash serves as a perfect metaphor for ocean mysteries in general, phenomena that can be scientifically explained, but still retain their power to inspire wonder. Like a brief window into another world, the flash comes and goes in an instant, leaving observers questioning whether they really saw what they think they saw. In a world increasingly dominated by digital experiences and virtual realities, such genuine moments of natural wonder become all the more precious. But while the green flash is a visual mystery that scientists have largely explained, our next phenomenon is a more recent discovery, an auditory enigma from the depths that continues to puzzle researchers. Deep beneath the frozen surface of Antarctica's Ross Sea, something is making a sound that shouldn't be there, a sound that raises questions about what might be happening in one of Earth's most remote and inhospitable environments. In the frozen waters surrounding Antarctica lies one of the ocean's newest and most perplexing mysteries, a strange, haunting sound that scientists have dubbed the Ross Sea Whistle. First detected in 2005 by underwater microphones monitoring the Antarctic waters, this unusual acoustic phenomenon has puzzled researchers ever since. Unlike many underwater sounds that can be quickly attributed to known sources like whale calls, ship engines, or seismic activity, the Ross Sea Whistle defies easy explanation, creating an acoustic enigma in one of Earth's most remote environments. The sound itself is unlike anything previously recorded in the ocean. It begins as a low, almost imperceptible moan that gradually rises in pitch over the course of about 2 minutes, eventually transforming into what can only be described as an eerie, almost musical whistle that echoes through the frigid waters before abruptly cutting off. What makes this sound particularly mysterious is its consistency and duration. It isn't a brief, one-time occurrence, but a repeating pattern that has been detected regularly during the Antarctic spring and summer months for years. The Ross Sea is already one of the most inhospitable environments on our planet. Located off the coast of Antarctica, it remains frozen for much of the year, with massive ice shelves extending out from the continent. During the brief Antarctic summer, parts of the sea open up, creating a dynamic environment where ice, water, and land interact in complex ways. It's a place of extremes, extreme cold, extreme isolation, and apparently, extremely unusual sounds. When researchers first captured the whistle on hydrophones, underwater microphones designed to record ocean sounds, they initially suspected it might be biological in origin. The oceans are filled with the vocalizations of marine mammals, from the complex songs of humpback whales to the clicking communications of dolphins. But the Ross Sea Whistle doesn't match any known biological sound pattern. Its duration is too long, its frequency range too unusual, and its regularity too precise to be attributed to any known marine creature. After ruling out biological sources, scientists began exploring geological explanations. Could it be the sound of ice shelves cracking and grinding against each other, perhaps underwater volcanic activity or the movement of sediment along the seafloor? These too were considered and largely dismissed. While ice can create a stunning variety of sounds, from high-pitched squeals to deep booms as it cracks and shifts, the particular pattern of the Ross Sea Whistle doesn't match these known ice acoustics. Some researchers propose that the sound might be created by a phenomenon known as thermal cracking. When ice warms and cools, it can expand and contract, creating stresses that result in cracking. This process can generate sounds, but typically these are sharp, relatively brief acoustic events, nothing like the prolonged, rising whistle that characterizes this Antarctic mystery. Another possibility involves water moving through crevices or tunnels in the ice, a kind of natural pipe organ created by Antarctica's unique geography. As water flows through narrow passages, it can create resonant frequencies that amplify into audible tones. This hypothesis remains one of the more plausible explanations, but it still doesn't fully account for the precise pattern and consistency of the whistle. Perhaps the most intriguing aspect of the Ross Sea Whistle is its apparent seasonality. The sound is most commonly detected during the Antarctic spring and early summer, when the ice begins to break up and melt. This correlation with seasonal changes suggests that whatever creates the sound is linked to this annual cycle of freezing and thawing. But exactly how this process generates such a structured, almost musical sound remains elusive. The mystery deepened when researchers noticed that the whistle seemed to change slightly from year to year, its frequency shifting, its duration extending or contracting in ways that hinted at a response to changing environmental conditions. As global climate change accelerates the melting of Antarctica's ice, these subtle variations in the whistle could potentially provide important clues about how the continent's ice structures are responding to warming temperatures. This connection to climate change has elevated the Ross Sea Whistle from mere scientific curiosity to potentially valuable data point. If researchers can definitively determine what causes the sound and how it relates to ice conditions, the whistle could serve as an acoustic barometer for the health of Antarctica's ice shelves, an early warning system for significant changes in this critical region. Some research teams have attempted to localize the sound, using arrays of hydrophones to triangulate its source. These efforts have pointed to a general area near the edge of the Ross Ice Shelf, where the massive sheet of ice meets the open water of the Ross Sea. This transitional zone, neither fully solid nor fully liquid, may be key to understanding the acoustic mystery. The investigation into the Ross Sea whistle highlights just how little we know about the acoustic environment of our oceans, particularly in remote regions like Antarctica. Until relatively recently, our understanding of underwater soundscapes was extremely limited. The development of advanced hydrophones and sound monitoring networks has opened up a new world of acoustic phenomena, many of which we're still struggling to explain. The oceans are, in many ways, nature's greatest concert hall, filled with sounds both beautiful and bizarre. From the haunting songs of humpback whales to the crackling of pistol shrimp and the low-frequency rumble of earthquakes, the underwater world is anything but silent. The Ross Sea whistle joins a growing catalog of mysterious ocean sounds, including the famous Bloop, an ultra-low frequency sound recorded in the Pacific in 1997 that was eventually attributed to icequakes, and the Upsweep, an unidentified sound that has been recorded in the Pacific since the early 1990s. What makes these acoustic mysteries so compelling is that sound travels differently in water than in air. In the ocean, sound waves can travel for hundreds or even thousands of miles under the right conditions. This means that the source of an underwater sound could be extraordinarily far from where it's detected, adding another layer of complexity to these investigations. The Ross Sea whistle also points to a broader truth about ocean exploration, that we often discover new mysteries faster than we solve old ones. Each new technology we deploy, each new region we study, seems to reveal phenomena that challenge our understanding. Far from having thoroughly explored our planet's oceans, we have barely scratched the surface of their secrets. In the case of the Ross Sea whistle, research continues. Scientific expeditions to Antarctica now routinely include acoustic monitoring equipment specifically designed to capture and analyze this strange sound. Advanced computer models are being developed to simulate how sound travels through the unique environment of the Ross Sea, attempting to reverse engineer the whistle to determine its source. Some researchers are even deploying autonomous underwater vehicles, equipped with hydrophones to patrol the areas where the whistle has been detected, hopping to catch the sound in the act of being created and finally identify its origin. Until then, the Ross Sea whistle remains one of the ocean's newest and most intriguing mysteries, a ghostly voice from one of Earth's most extreme environments that reminds us how much we still have to learn about our planet's waters. It stands as testimony to the fact that even in an age of satellites, supercomputers, and global sensors networks, nature still holds secrets that elude our understanding. The whistle joins our other ocean mysteries: the Baltic Sea anomaly with its UFO-like appearance, the terrifying power of rogue waves, and the breathtaking beauty of the green flash, as phenomena that exist at the boundary between the known and the unknown. Each in its own way challenges us to look deeper, listen more carefully, and approach the natural world with humility and wonder. As we continue to explore the oceans that cover more than 70% of our planet's surface, we can expect to uncover even more unexplained phenomena, more mysteries that will challenge our understanding and ignite our imagination. The seas have always been a source of wonder and fear, of discovery and legend. Even as science explains some of their secrets, new questions emerge from the depths, ensuring that the oceans will remain Earth's last great frontier for generations to come. Imagine a world where entire landmasses can simply disappear, not gradually eroded by time or slowly consumed by rising waters, but vanished as if they never existed at all. This isn't science fiction or some ancient legend. This is the strange case of Bermeja, a phantom island that challenges our understanding of geography, politics, and perhaps reality itself. Bermeja was once a fixture on maps of the Gulf of Mexico, positioned approximately 160 kilometers north of the Yucatan Peninsula. For over 3 centuries, this island appeared on nautical charts and official documents, guiding sailors through these waters with the promise of solid ground amid the endless blue. Spanish explorers first documented Bermeja in the early 16th century, describing a modest island with striking reddish soil, hence its name, which means vermilion in Spanish. The island wasn't just a speck on a map. It was substantial enough to be considered valuable, strategically positioned in waters rich with marine life and potentially hiding oil reserves beneath its shores. But here's where things get truly strange. When modern researchers went looking for Bermeja, they found absolutely nothing. The island had vanished without a trace. In the year 2000, a Mexican research vessel conducted an extensive search for the island using the precise coordinates that had been recorded for centuries. The scientists expected to find at least some evidence, perhaps an underwater formation, a reef, or a shoal, something to explain why generations of cartographers had marked this location. But the expedition found only open ocean. The seafloor showed no signs that an island had ever existed there. No geological formations, no ruins, nothing that would suggest land had once broken the surface at these coordinates. The mystery deepened in 2009 when another expedition, this one backed by the Mexican government and using sophisticated sonar equipment, again failed to find any trace of Bermeja. The island that had been documented for over 300 years had simply ceased to exist, if it had ever existed at all. This vanishing act has spawned numerous theories, ranging from the scientific to the conspiratorial. The most straightforward explanation is that Bermeja was nothing more than a cartographic error, a mistake copied from one map to another over centuries, gaining legitimacy through repetition rather than reality. Perhaps early explorers mistook a temporary sandbar or a low-lying reef visible only at certain tides for an actual island. Maybe they witnessed a volcanic eruption that created a temporary landmass, which later sank back beneath the waves. But these explanations struggle to account for the detailed descriptions of the island that exist in historical records. Spanish documents don't just note its existence, they describe its appearance, its color, and in some cases even its features. Were all of these observations fabricated? And if so, why? Some researchers point to natural phenomena as the culprit. Perhaps Bermeja was destroyed by a powerful hurricane, its soil and structure completely washed away by the relentless force of wind and waves. Others suggest underwater earthquakes could have caused the island to sink beneath the sea, similar to how entire coastal regions have disappeared throughout history during severe seismic events. There's evidence that the Caribbean plate is exceptionally active, with underwater landslides capable of dramatically altering the seafloor. Could Bermeja have been a victim of such geological violence? If so, wouldn't there be some trace left behind, some underwater formation that would indicate where the island once stood? The timing of Bermeja's final disappearance has led to more controversial theories. The island's location would have been extremely valuable in establishing maritime boundaries and economic zones between Mexico and the United States. Under international law, territorial waters extend 200 nautical miles from a nation's coastline, and Bermeja, had it existed, would have expanded Mexico's claim to potentially oil-rich waters in the Gulf. This has led some to suggest that the island was deliberately erased, either from maps or from reality itself. Could powerful interests have altered charts and documents to eliminate an inconvenient geographical feature? Some Mexican politicians have even publicly suggested that the island was somehow physically destroyed to prevent their country from claiming valuable oil reserves. While such theories might seem far-fetched, the history of cartography is indeed filled with both honest mistakes and deliberate fabrications. Phantom islands appear throughout the historical record, sometimes as genuine errors, sometimes as traps set by mapmakers to catch copyright infringement, and sometimes as deliberate frauds intended to secure territorial claims or funding for explorations. What makes Bermeja particularly puzzling is its persistence. Unlike many phantom islands that appeared on just a few maps before being disproven, Bermeja remained a cartographic fixture for centuries. It wasn't just on obscure charts either. It appeared on official maps produced by the Spanish Empire, later Mexican government documents, and even United States naval charts well into the 20th century. Some researchers have turned to historical shipping records, searching for accounts of vessels that might have visited or at least passed by Bermeja. These investigations have yielded conflicting results. While some old logbooks contain what appear to be references to the island, others show ships passing directly through its supposed location without noting any landmass. This inconsistency only deepens the mystery. Perhaps the answer lies somewhere in between the various theories. Maybe Bermeja was a small, low-lying island that gradually eroded over time, finally disappearing beneath the waves sometime in the 19th or early 20th century. Natural processes could have been responsible for its disappearance, while political interests might explain the reluctance to update maps until the matter became impossible to ignore. Or perhaps there's another explanation, one tied to the strange phenomena that sometimes occur at sea. Sailors for centuries have reported unusual optical illusions caused by specific atmospheric conditions. Fata Morgana, a complex form of mirage, can make distant objects appear to float above the horizon or create the appearance of cliffs, mountains, or islands where none exist. Could early explorers have been deceived by such phenomena, mistaking a mirage for an actual island? What's particularly eerie about Bermeja is that it's not alone in its disappearance. The oceans are home to dozens of phantom islands, landmasses that were once confidently mapped and described, but have since been proven not to exist. The Mary Celeste Reef, Sandy Island in the Pacific, Emerald Island near Australia, all were once considered real places, all appeared on official maps, and all have since been revealed to be non-existent. This pattern forces us to question how much we truly know about our world. We tend to think of modern maps as definitive and accurate, forgetting that much of our understanding of remote regions comes from surveys conducted decades or even centuries ago. Even with satellite imagery and GPS technology, there remain areas of our planet, particularly beneath the oceans, that are less thoroughly documented than the surface of Mars. The case of Bermeja reminds us that our knowledge is always evolving, always being revised. What we accept as geographical fact today may be dismissed as error or fiction tomorrow. And occasionally, as with this phantom island, we're left with a genuine mystery that resists simple explanation. Whether Bermeja was a cartographic error, a natural island lost to the sea, or something else entirely, its story speaks to the enduring mystery of our oceans. These vast bodies of water that cover most of our planet still hold secrets, still confound our expectations, and still occasionally make things, even entire islands, vanish without a trace. And perhaps that's why stories like Bermeja's continue to fascinate us. In an age where we can instantly view almost any place on Earth through our phones, there's something compelling about the idea that the world can still surprise us, that not everything has been definitively mapped and categorized, that mystery itself hasn't vanished from our increasingly documented world. As we sail away from the enigma of Bermeja, remember that the ocean floor remains one of the least explored regions on our planet. Less than 20% has been mapped in detail, leaving the vast majority shrouded in darkness and mystery. What other secrets might be hiding in those unexplored depths? What other islands, structures, or phenomena remain undiscovered, or perhaps, like Bermeja, have disappeared without leaving evidence they ever existed at all? When we think of black holes, our minds immediately drift to the cosmos, those mysterious regions in space where gravity becomes so intense that nothing, not even light, can escape. But what if I told you that similar phenomena exist right here on Earth, spinning in our oceans, creating massive vortexes that can stretch for hundreds of miles and persist for years? These aren't cosmic anomalies, they're oceanic eddies, sometimes called the black holes of the ocean, and they represent one of the most powerful and least understood forces in our planet's waters. These oceanic black holes aren't actually holes in the physical sense. They're massive circular currents, spinning bodies of water that break away from main ocean currents and develop lives of their own. Imagine a whirlpool, but on an almost unimaginable scale. Some of these vortexes can span 150 miles in diameter and extend hundreds of feet deep into the ocean. Unlike the whirlpools we might visualize from stories and legends, which typically last minutes or hours, these oceanic eddies can persist for months, sometimes even years, traveling vast distances across our seas. What makes these phenomena particularly fascinating, and earned them their ominous nickname, is the way they trap and transport water. Just as cosmic black holes capture whatever crosses their event horizon, these oceanic vortexes trap water inside their spinning borders, creating a distinct body of water that moves through the ocean without mixing with the surrounding sea. Like cosmic black holes that consume everything within reach, these ocean eddies can capture and transport marine life, debris, pollutants, and even other, smaller eddies within their powerful circular currents. Scientists have identified two main types of these vortexes: cyclonic and anticyclonic eddies. Cyclonic eddies spin in the same direction as the Earth's rotation in their respective hemisphere, counterclockwise in the northern hemisphere and clockwise in the southern. These eddies cause water to diverge from their centers, creating a slight depression on the ocean surface that can actually be detected by satellite. More importantly, this divergence draws deeper, colder, nutrient-rich water upward in a process called upwelling. Anticyclonic eddies, on the other hand, spin in the opposite direction to Earth's rotation. They cause water to converge toward their centers, creating a slight bulge on the ocean's surface, sometimes rising up to 3 feet higher than the surrounding water. This convergence pushes surface water downward, taking warmer water to unusual depths. Both types of these massive vortexes can dramatically alter local ocean conditions. The temperature inside an eddy can differ from the surrounding ocean by up to 8 degrees Celsius, a massive difference in oceanic terms. This temperature variation, along with differences in salinity and oxygen levels, creates what are essentially unique ecosystems that move through the larger ocean environment. What's particularly mysterious about these oceanic black holes is how they form and why they behave as they do. Most originate from instabilities in major ocean currents. When these powerful flows of water encounter underwater mountains, islands, or other obstacles, they can begin to meander and eventually form loops that pinch off into separate, spinning masses of water. But some eddies seem to form spontaneously in ways that continue to puzzle oceanographers. The Gulf Stream, that massive river within the Atlantic Ocean, is particularly famous for generating these vortexes. As this powerful current flows north along the eastern coast of North America, it regularly spawns eddies that break away and begin journeys of their own. Some drift back toward the American coastline, while others venture far out into the Atlantic, carrying their captive water and marine life thousands of miles from their origin point. Perhaps the most famous of these oceanic black holes are the rings that form in the Agulhas Current off the coast of South Africa. These massive eddies, known as Agulhas rings, break off from the current and travel northwest into the Atlantic Ocean. Each ring carries an enormous amount of salt and heat, equivalent to the energy of hundreds of nuclear power plants running continuously for months. These rotating bodies of water can be detected from space due to their distinct temperature signatures, and the way they slightly deform the ocean's surface. What makes these vortexes particularly enigmatic is their seeming intelligence, the way they navigate around obstacles, merge with or repel other eddies, and maintain their integrity across vast distances. Some researchers have noted that these massive oceanic features display behaviors reminiscent of living organisms, as if they possess a kind of rudimentary consciousness guiding their movements through the seas. This isn't to suggest that these ocean black holes are actually alive or sentient. Rather, they represent emergent properties of fluid dynamics, showcasing how simple physical laws can create incredibly complex systems that appear to exhibit purposeful behavior. It's a reminder that the boundary between inanimate and animate systems isn't always as clear as we might imagine. The ecological impact of these spinning water masses is profound and still not fully understood. They transport heat, salt, nutrients, and marine life across vast oceanic regions, potentially contributing to climate regulation on a global scale. When cold water eddies bring nutrient-rich deep water to the surface, they can trigger plankton blooms that ripple up through the food chain, creating oases of life in otherwise nutrient-poor regions of the open ocean. For marine creatures, these vortexes can be both blessing and curse. Some species appear to seek out these spinning water masses, using them as foraging grounds or transportation across vast ocean distances. Others find themselves unwittingly trapped inside, carried far from their normal habitats to regions where they may not be adapted to survive. Human activities are also affected by these mysterious ocean features. Shipping routes must sometimes be adjusted to avoid particularly powerful eddies that could push vessels off course or cause dangerous conditions. Oil and gas operations in offshore regions have to account for these unpredictable vortexes that can disrupt currents around drilling platforms. And perhaps most critically, these oceanic black holes can complicate search and rescue operations by unpredictably altering the drift patterns of people or objects lost at sea. Scientists are only beginning to understand the full significance of these massive ocean vortexes. Recent research suggests they may play a crucial role in mixing ocean layers that would otherwise remain separate, helping to distribute heat throughout the world's seas and potentially influencing global climate patterns. Some studies indicate they might even contribute to the ocean's ability to absorb carbon dioxide from the atmosphere, making them important players in regulating greenhouse gases. What's particularly fascinating is how these oceanic black holes interact with each other and with other ocean features. They can merge like soap bubbles, spinning around each other in an oceanic dance before combining into a single, larger eddy. They can split apart, spawning smaller vortexes that inherit properties from their parent. They can even repel each other like magnets with the same polarity, bouncing off invisible boundaries created by their rotating currents. The study of these features has been revolutionized by satellite technology, which allows scientists to track these massive vortexes from space. Advanced radar altimeters can detect the subtle differences in ocean height created by these spinning water masses, while thermal imaging can identify the temperature differences between the eddy and surrounding waters. What once required ships to physically sail through these features to detect them can now be observed continuously from orbit, revealing patterns and behaviors that would otherwise remain hidden. Yet despite these technological advances, much about these oceanic black holes remains mysterious. Predicting their formation, movement, and dissolution continues to challenge our most sophisticated ocean models. Their influence on weather patterns, marine ecosystems, and global climate systems is still being discovered. And their sheer scale and power, some containing energy equivalent to major hurricanes, reminds us of how small human endeavors are compared to the massive forces constantly at work in our oceans. As we continue to study these fascinating ocean vortexes, we're reminded that our planet's waters are not simply uniform, static environments. They're dynamic, ever-changing systems filled with features that challenge our understanding and occasionally defy our predictions. Like their cosmic namesakes, the black holes of our oceans represent frontier science, phenomena at the edge of our knowledge that invite us to look deeper, question our assumptions, and recognize how much remains to be discovered about the blue world that covers most of our planet. Picture yourself on a small boat gliding through dark waters at night. The air is warm, heavy with tropical moisture, and as your hand trails through the water, something magical happens. The sea begins to glow. Each movement of your fingers leaves behind a trail of blue-green light, as if you're drawing with liquid starlight across the surface of the ocean. This isn't fantasy or fiction. It's the reality of Puerto Rico's bioluminescent bays, where millions of microscopic organisms create one of nature's most enchanting light shows. These glowing waters represent one of the most mesmerizing natural phenomena on our planet. Puerto Rico is home to 3 of the world's few consistently bioluminescent bays: Mosquito Bay on Viques Island, Laguna Grande in Fajardo, and La Pargara in Lajas. Of these, Mosquito Bay is considered the brightest, recognized by the Guinness Book of World Records as the most intense bioluminescent bay recorded on Earth. But what exactly causes this ethereal glow, and why does it occur in these specific locations? The answer lies in a tiny organism called Pyrodinium bahemans, a species of dinoflagellate that measures less than 1/500th of an inch across. These single-celled plankton are a type of marine algae that possess the remarkable ability to produce light through a chemical reaction. While bioluminescence itself isn't rare in the ocean, scientists estimate that more than 90% of creatures living in open ocean depths can produce light in some form. The concentration of these particular organisms in Puerto Rico's bays creates a display of unprecedented brilliance. Each milliliter of water in these bays can contain up to 700,000 individual dinoflagellates. When undisturbed, these microscopic organisms remain invisible to the naked eye. But when agitated by a swimming fish, a paddle stroke, rainfall hitting the surface, or even your hand moving through the water, they emit a brief, vivid flash of blue-green light. This light is produced through a chemical reaction involving a substance called luciferin, named after Lucifer, the light bearer, and an enzyme called luciferase. When the dinoflagellate is disturbed, these chemicals mix with oxygen, producing the characteristic glow in a process that's remarkably efficient. Nearly 100% of the energy involved is converted to light rather than heat. But why do these organisms produce light at all? Scientists believe this bioluminescent ability serves as a defense mechanism. When a small creature attempts to eat the dinoflagellates, the sudden flash of light may startle the predator or attract larger predators that might threaten the initial attacker, a brilliant evolutionary strategy for survival. It's nature's version of a burglar alarm, using light instead of sound to call for help and deter threats. What makes Puerto Rico's bays particularly special is the unique combination of environmental factors that allow these dinoflagellates to thrive in such extraordinary numbers. These bays typically have narrow entrances connecting to the sea, which limits water exchange and helps maintain stable populations of the light-producing organisms. The surrounding mangrove forests are crucial to this ecosystem, releasing vitamin B12 that nourishes the dinoflagellates. The shallow, warm waters provide ideal growing conditions, and the limited pollution and light interference in these areas allow the natural bioluminescence to shine without competition. The result is nothing short of magical. Kayakers and swimmers in these waters find themselves surrounded by what appears to be floating constellations. Fish swimming below the surface become visible as glowing torpedoes, trailing luminous wakes behind them like underwater comets. Even raindrops create tiny explosions of light as they hit the surface, as if the stars themselves were falling directly into the bay. Mosquito Bay on Viques Island represents the pinnacle of this phenomenon. Despite its name, which actually comes from a ship called El Mosquito rather than the insect. This bay offers the most reliable and spectacular display of bioluminescence on the planet. Its waters can contain up to 700,000 dinoflagellates per gallon, a concentration so high that on moonless nights, the glow is bright enough to read by. The bay's isolation has helped preserve its unique ecosystem, though it remains vulnerable to environmental changes. In 2017, Hurricane Maria devastated Puerto Rico and temporarily dimmed Mosquito Bay's famous glow. For several months after the storm, the bioluminescence was barely visible, leading to fears that this natural wonder might have been permanently damaged. Scientists discovered that the hurricane had altered the bay's salinity by dumping massive amounts of freshwater into the ecosystem, disrupting the delicate balance needed for the dinoflagellates to thrive. Fortunately, the bay eventually recovered, and the organisms gradually returned to their previous concentrations, restoring the magical light show that has captivated visitors for generations. What many visitors don't realize is that these bioluminescent bays are extremely rare on a global scale. While various forms of bioluminescence can be found throughout the world's oceans, the specific conditions required for a consistent, year-round display of this intensity exist in only a handful of locations worldwide. Jamaica's Luminous Lagoon, Halong Bay in Vietnam, and Jervis Bay in Australia feature similar phenomena, but Puerto Rico's bays, particularly Mosquito Bay, remain unmatched in their brilliance and reliability. The science behind these glowing waters continues to fascinate researchers. The light produced by Pyridinium bahemans peaks at a wavelength of 470 nanometers, a blue-green color that happens to travel particularly well through seawater. This optimal wavelength suggests an evolutionary adaptation specifically suited to the marine environment, allowing the light signal to be seen by potential predators from greater distances. What's particularly interesting is how these organisms synchronize their light production. When one dinoflagellate flashes, others nearby often flash in response, creating waves of light that ripple through the water. This synchronized flashing may enhance the defensive effect, creating a more disorienting display for potential predators. Some scientists have compared this behavior to other biological synchronization phenomena, such as fireflies blinking in unison or crickets chirping together. Complex, emergent behaviors arising from simple organisms responding to their environment and each other. The fragility of these bioluminescent ecosystems cannot be overstated. Changes in water temperature, acidity, or pollution levels can dramatically reduce dinoflagellate populations. Urban development near these bays brings light pollution that diminishes the visible impact of the bioluminescence. Agricultural runoff can introduce chemicals that disrupt the delicate balance of nutrients needed for these organisms to thrive. And ironically, the tourism drawn by these natural wonders can itself become a threat if not carefully managed. In recognition of this fragility, Mosquito Bay was designated a nature reserve in 1989. Tour operators now follow strict guidelines to minimize their environmental impact. Motorboats, which can leak petroleum products harmful to the dinoflagellates, are largely prohibited, with most tours using kayaks, electric motors, or traditional rowing boats instead. Swimming is restricted in some areas to prevent the introduction of chemicals from sunscreen, insect repellent, and other personal care products that may harm the sensitive ecosystem. Research into these bioluminescent organisms extends beyond their ecological importance. The same chemical process that creates their glow has proven invaluable in medical and scientific research. Luciferase enzymes derived from bioluminescent organisms are now used as markers in various biological experiments, allowing scientists to track the expression of specific genes or the presence of particular substances. This application has revolutionized fields from cancer research to environmental monitoring, demonstrating how nature's innovations can inspire human technological advances. Perhaps what makes these bioluminescent bays most remarkable is the sense of wonder they evoke. In an age where digital screens dominate our visual experiences and artificial light pollutes our night skies, these glowing waters offer something increasingly rare, a natural phenomenon that seems almost magical in its beauty and unexpectedness. Visitors often describe their experience in these waters as transformative, a reminder of the astonishing capabilities of even the smallest forms of life. The bioluminescent bays of Puerto Rico stand as living laboratories, natural wonders, and fragile ecosystems that bridge the gap between scientific fascination and pure enchantment. They remind us that our oceans still hold phenomena that can inspire childlike wonder even as they push the boundaries of our scientific understanding. Places where the ordinary rules of our terrestrial experience seem suspended, replaced by something that feels like magic, but is, in fact, the result of billions of years of evolution's ingenious design. Beneath the waves off the southern coast of Japan lies a mystery so profound, it has been compared to the legendary lost city of Atlantis. Carved stone structures rest silently on the ocean floor, massive terraced formations, perfectly straight paths, immense stone circles, and even what appears to be a pyramid. This underwater complex, known as the Yonaguni Monument, has sparked fierce debate in archaeological circles and captured the imagination of people worldwide. Could this be evidence of an advanced ancient civilization that was swallowed by the sea? Did Japan once have its own Atlantis that vanished beneath the waves, leaving only these stone enigmas as testament to its existence? The story of this underwater mystery begins in 1985 when Kihachiro Arate, a diver searching for new spots to observe hammerhead sharks, stumbled upon something extraordinary off the coast of Yonaguni-jima, the westernmost inhabited island of Japan. What he found wasn't marine life, but what appeared to be massive stone structures with sharp angles, flat planes, and precise edges, features that seemed too regular, too intentional to be natural formations. The main structure, now often called the Yonaguni Monument or Yonaguni Submarine Ruins, rises about 90 feet from the ocean floor and is approximately 165 feet long. What makes these underwater formations so compelling and controversial are their apparently architectural features. The main monument includes what seem to be massive stone platforms with terraced edges, connected by what look like roads or ramps. There are near-perfect right angles cut into the rock, long straight channels that resemble ceremonial roads, and even a formation that bears a striking resemblance to a stepped pyramid. One of the most discussed features is what some researchers call the turtle, a massive stone carving that appears to represent this sacred animal. Nearby are other formations that some interpret as stone circles, pillars, and what might be the remains of walls or buildings. Adding to the site's mystery is its location at a seismically active meeting point between the Eurasian and Philippine sea plates. This area is prone to earthquakes and tsunami activity, suggesting a possible mechanism for how an ancient coastal settlement might have been suddenly submerged. Could a catastrophic seismic event have sunk an entire civilization in a single cataclysmic moment, much like the story of Atlantis? The timing could fit with known geological history. During the last ice age, which ended about 12,000 years ago, sea levels were much lower, approximately 130 feet below present levels. The Yonaguni structures currently sit at depths ranging from 60 to 100 feet underwater, meaning they would have been above sea level during this period. As the ice age ended and glaciers melted, rising seas could have gradually submerged what was once dry land, potentially taking an ancient settlement with it. This timeline aligns with some of humanity's earliest known monumental construction projects. Göbekli Tepe in Turkey, with its massive carved pillars, dates back about 12,000 years. If the Yonaguni Monument is indeed an artificial structure from a similar period, It would represent one of the oldest known human building projects, potentially predating the Egyptian pyramids by thousands of years and rewriting our understanding of prehistoric Asian civilizations. The controversy surrounding Yonaguni centers on a fundamental question: are these structures natural or man-made? The scientific community remains deeply divided. Some prominent researchers, like Professor Masaki Kimura from the University of the Ryukyus, who has studied the site for decades, firmly believe these are the remnants of a human-made structure. Kimura has documented what he interprets as quarry marks, stone tools, potential drainage channels, and even carvings that might represent animals or writing. After more than 2 decades of research, he concluded that the site could be the remains of a city that was destroyed by an earthquake and submerged approximately 5,000 years ago. Professor Kimura's theory gained support from some international researchers who noted similarities between the underwater structures and other ancient sites in Japan. The terraced appearance of the monument bears resemblance to the Asuka period stone structures found elsewhere in the Japanese archipelago, though those are much younger, dating from around the 6th to 7th centuries of the Common Era. However, many geologists and archaeologists remain skeptical, arguing that the formations can be explained through natural processes. They point out that the entire Yonaguni region consists of sandstone and mudstone that naturally breaks along plains, creating straight edges and angular formations. The regular terraced appearance, they suggest, could result from the natural tendency of these rock types to fracture along bedding plains, combined with the effects of tectonic activity, ocean currents, and differential erosion. Skeptics also note the absence of certain features typically associated with ancient human settlements. Despite numerous expeditions to the site, researchers have yet to find conclusive evidence of pottery, tools, human remains, or other artifacts that typically accompany human habitation. While supporters counter that such items could have been washed away by thousands of years of strong ocean currents, the lack of definitive archaeological evidence remains a significant challenge to the artificial origin theory. What makes the Yonaguni monument particularly challenging to study is that even if it was modified by human hands, those modifications may have been made to an already naturally distinctive formation. This creates a nearly impossible task of distinguishing between natural features and potential human alterations after thousands of years of erosion by powerful ocean currents. The cultural context adds another layer to the mystery. The Yonaguni monument lies near the Ryukyu archipelago, a chain of islands with a rich and ancient cultural history distinct from mainland Japan. The indigenous Ryukyuan people developed sophisticated trading networks and a complex society, though known historical records don't extend far enough back to connect directly with the potential age of the underwater structures. However, local folklore contains intriguing references that some researchers connect to the submerged formations. Traditional Ryukyuan legends speak of a land that vanished beneath the waves and of gods who taught humans various arts before returning to the sea. These stories, passed down through generations, bear striking similarities to other global flood myths and tales of lost civilizations, including the Atlantis legend itself. If the Yonaguni monument does represent the remains of an ancient human settlement, the implications for our understanding of history would be profound. It would require rethinking when complex human societies first emerged in East Asia, and would suggest that advanced stoneworking and monumental architecture developed independently in this region much earlier than previously thought. It might even indicate that prehistoric humans possessed seafaring capabilities beyond what mainstream archaeology currently recognizes, allowing them to establish communities on remote islands. The possibility that these structures might be artificial has led to more speculative theories as well. Some researchers have proposed connections between the Yonaguni formations and other prehistoric Pacific cultures, suggesting ancient contact or shared origins with civilizations from Polynesia or even South America. Others have drawn parallels to other underwater formations found worldwide, proposing the controversial idea of a global maritime civilization that existed during the last ice age before rising seas submerged coastal settlements around the world. What's certain is that the ocean floor around Japan holds more secrets yet to be fully explored. In recent years, additional underwater structures have been identified near Okinawa and other Japanese islands. While many of these are likely natural formations, their discovery highlights how little we still know about the submerged landscapes that once stood above sea level and the human histories that might have unfolded upon them. The Yonaguni Monument reminds us that our understanding of human prehistory remains incomplete. The conventional narrative of civilization's development, with agriculture emerging around 12,000 years ago, followed by permanent settlements, and eventually leading to monumental architecture, continues to be challenged by discoveries around the world. From Göbekli Tepe's massive stone circles to submerged sites off the coasts of India, the Mediterranean, and now Japan, we find evidence suggesting our ancestors may have been more technologically sophisticated earlier in our timeline than we previously believed. Whether natural wonder or lost civilization, the Yonaguni Monument embodies one of the most profound mysteries of our oceans. It represents the tantalizing possibility that evidence of our distant past may lie preserved beneath the waves, waiting to rewrite our understanding of human history. And perhaps most compellingly, it reminds us that the boundary between natural and artificial, between the random processes of geology and the intentional creations of human minds, can sometimes blur into something that challenges our very definitions of these categories. As technology advances and underwater archaeology becomes more sophisticated, the true nature of the Yonaguni Monument may eventually be determined. Until then, it remains Japan's Atlantis, a silent, submerged enigma that continues to challenge our understanding of both natural processes and human history, inviting us to question what other secrets might still lie hidden beneath the world's oceans, waiting to be discovered. The strange case of sea serpent sightings, cryptid or misidentification. Throughout maritime history, there are tales that even the most hardened sailors hesitate to share. Stories of massive serpentine creatures gliding through ocean waves, their colossal bodies stretching longer than the ships that spot them. These aren't myths from ancient scrolls or legends passed down through generations. These are documented sightings, reported by naval officers, ship captains, and ordinary people who swear they've witnessed something that shouldn't exist in our oceans. Sea serpents, as they've come to be known, represent one of the most persistent mysteries of the deep, a phenomenon that continues to divide the scientific community. Are they misidentifications of known animals, or could there truly be something undiscovered lurking beneath the waves? The modern history of sea serpent sightings begins in earnest in the 19th century, though accounts stretch back thousands of years. One of the most famous encounters occurred in August 1817, when the crew and passengers of the HMS Daedalus, a British Royal Navy vessel, spotted something extraordinary in the South Atlantic. The ship's captain, Peter McQuhie, along with several officers and crew members, observed what they described as a 60-foot serpentine creature with its head held 4 feet above the water. It moved with purpose through the waves, its dark body undulating just beneath the surface. What makes this sighting particularly compelling is the credibility of the witnesses. These weren't superstitious sailors prone to tall tales. These were educated naval officers who risked their reputations by coming forward. Captain McQuhie even submitted detailed reports to the British Admiralty and the Times newspaper, standing firm in his conviction despite facing ridicule from some scientific quarters. When pressed about what he had seen, McQuhie responded with unwavering certainty. "We saw this creature with our own eyes. I am convinced it was not a whale, nor any marine animal known to science." But the Daedalus incident is far from isolated. In 1905, two naturalists aboard the yacht Valhalla reported seeing a long-necked, turtle-bodied creature off the coast of Brazil. The Norwegian naval vessel Sengen documented something similar in 1947. The list of credible witnesses goes on and on, spanning centuries and oceans across the globe. So what exactly are people seeing? The scientific community has proposed numerous explanations over the years. One of the most common is that sea serpent sightings are actually misidentifications of known marine animals viewed under unusual circumstances. Giant oarfish, which can grow up to 36 feet long with bright red crests on their heads, are often suggested as the culprits. These rare deep-sea dwellers occasionally wash up on shores or venture into shallow waters when dying or distressed, potentially accounting for some sightings. Other explanations include lines of dolphins swimming in formation, creating the illusion of a single undulating body, or massive marine mammals like whale sharks, or even entangled masses of seaweed draped over partially submerged debris. Perspective plays tricks on the human eye, especially at sea where judging size and distance becomes challenging against the vast backdrop of ocean. Yet there's something unsatisfying about these explanations when you examine the consistency of descriptions across different eras and locations. Many witnesses specifically rule out these possibilities, clearly stating that what they observed was unlike any known animal. The details often align eerily well: the distinctive head held above water, the humps or coils visible along the body, and the impressive length that dwarfs nearby vessels. The scientific establishment has largely dismissed the possibility of unknown giant serpentine creatures hiding in our oceans. After all, wouldn't we have found physical evidence by now? No confirmed carcasses have ever been recovered, no definitive photographs exist, and no bones have been discovered that couldn't be attributed to known species. In an age where we've mapped the ocean floor and tracked the migrations of the planet's largest animals, the absence of concrete evidence seems damning. But here's where the mystery deepens. We actually know surprisingly little about our oceans. More than 80% of Earth's oceans remain unmapped, unobserved, and unexplored. The deep sea represents the largest and least understood habitat on our planet. New species are discovered regularly, including some quite large ones. The megamouth shark, which can grow to 18 feet long, wasn't discovered until 1976. The colossal squid, potentially reaching 46 feet in length, was known only through fragments until a complete specimen was caught in 2007. Could something large and elusive still be lurking in the vast, unexplored depths? Some researchers suggest that if sea serpents do exist, they might be relic populations of prehistoric marine reptiles. The fossil record shows that massive aquatic reptiles once dominated our oceans: mosasaurs, plesiosaurs, and ichthyosaurs, some bearing striking resemblances to descriptions of sea serpents. The conventional understanding is that these creatures went extinct alongside the dinosaurs around 66 million years ago. But the discovery of living fossils like the coelacanth, a fish thought extinct for 70 million years until found alive in 1938, raises intriguing possibilities. Others propose more radical theories, that these creatures represent entirely unknown evolutionary lineages, animals that have somehow evaded scientific classification despite their size. The deep ocean trenches, with their extreme pressures and temperatures, could harbor life forms adapted to conditions we can barely comprehend, occasionally venturing to the surface and into human view. One of the most puzzling aspects of sea serpent reports is their apparent decline in recent decades. Despite more people being at sea than ever before, equipped with cameras and video recorders, clear documentation remains elusive. Some attribute this to changing sea conditions due to pollution and climate change, driving deep-dwelling creatures further from human contact. Others suggest that increased ocean noise from shipping and naval activities might be pushing these shy creatures into even more remote regions. But perhaps the most compelling explanation for the decrease in sightings is simply that we've stopped looking. In our modern world, where satellite imagery and sonar mapping give us the illusion of complete knowledge, the space for mystery has shrunk. Sailors no longer keep the same vigilant watch for unusual phenomena, and when something strange is spotted, it's often dismissed before being properly documented. The case of sea serpents raises profound questions about how we approach the unknown. The scientific method demands evidence, but it also requires openness to possibilities that challenge established understanding. Throughout history, many creatures now accepted as real were once dismissed as myths, the giant squid, the mountain gorilla, and the platypus among them. Each was met with ridicule until physical evidence forced a reconsideration. What would constitute proof of sea serpents? A body would be the gold standard, but if these are rare, deep-dwelling creatures, a corpse might be quickly scavenged or decomposed before reaching shore. Clear photographic or video evidence would help, though in an age of digital manipulation, even this might not be persuasive enough for hardcore skeptics. The most likely path to confirmation would be through organized scientific expeditions specifically designed to search for and document these elusive creatures. Some researchers have begun using environmental DNA sampling, collecting water samples to detect genetic material shed by organisms in the area. This cutting-edge technique has already revealed the presence of previously unknown species in various habitats. Could it someday detect the genetic signature of something matching the description of sea serpents? The possibility remains open. The ocean is vast, deep, and still largely mysterious to us. Less than 20% of its volume has been explored, and new discoveries are made regularly that force revisions to our understanding of marine ecosystems. If sea serpents do exist, whether as unknown species or misunderstood known ones, they represent a humbling reminder of how much we still have to learn about our own planet. Perhaps the most balanced approach is to maintain healthy skepticism while acknowledging the limits of our knowledge. The history of science is filled with examples of established certainties being overturned by new discoveries. As the great zoologist Bernard Heuvelmans once noted, the cardinal sin in science is not the pursuit of unlikely possibilities, but the premature dismissal of possibilities altogether. So the next time you find yourself gazing out over the ocean's seemingly endless expanse, consider this. Beneath those waves could be creatures and phenomena that defy our current understanding. The sea keeps its secrets well, revealing them only in fleeting glimpses that leave us questioning what we know about the natural world. Are sea serpents real? The answer remains elusive, hidden somewhere in the vast blue depths that cover most of our planet. And perhaps that mystery, that tantalizing possibility of the unknown, is precisely what continues to draw us to these stories, generation after generation. In the intricate machinery of our planet's climate system, few components are as crucial as the Gulf Stream. This massive ocean current, flowing like an underwater river through the Atlantic, carries warm water from the Gulf of Mexico northward along the eastern coast of North America before crossing the Atlantic toward Europe. For centuries, we've taken this current for granted, a constant force that shapes weather patterns, moderates climates, and influences everything from fisheries to shipping routes. But in recent years, scientists have observed something deeply troubling. The Gulf Stream appears to be changing, weakening in ways that defy our expectations and potentially threaten the climatic stability we've built our civilization around. What's happening to this vital ocean current, and what might it mean for our future? To understand the mystery of the Gulf Stream anomaly, we first need to appreciate the current's extraordinary importance. The Gulf Stream isn't just moving water, it's transporting heat on a planetary scale. Every second, it carries approximately 150 million cubic meters of water, more than 100 times the combined flow of all the rivers on Earth. This massive movement of warm water acts like a natural heating system for Western Europe, keeping countries like Ireland, the United Kingdom, and Norway much warmer than they would otherwise be at their northern latitudes. The science behind the Gulf Stream's flow is complex but follows fundamental principles. As warm water from the tropics moves northward, it gradually cools, releasing heat to the atmosphere. This heat transfer is what gives places like London and Paris their relatively mild winters despite being at the same latitude as cold regions of Canada. As the water continues to cool in the North Atlantic, it becomes denser and eventually sinks, creating a deep-water return flow that completes a vast oceanic conveyor belt known as the Atlantic Meridional Overturning Circulation, or AMOC. For thousands of years, this system has remained remarkably stable, with only minor fluctuations. Historical records and geological evidence suggest that the Gulf Stream has maintained its current configuration throughout human civilization. It's one of those planetary systems we've come to see as permanent, as reliable as the sunrise or the changing of seasons. But beginning around 2004, oceanographers started detecting unusual patterns. Instruments deployed across the Atlantic revealed that the Gulf Stream was slowing down, weakening by approximately 15% since the mid-20th century. Even more alarming, its path was showing signs of instability, with portions of the current temporarily diverting from their usual routes. These shifts, though seemingly small on a global scale, represent dramatic changes in a system that typically evolves over thousands or tens of thousands of years. The first major anomaly was detected in 2010, when monitors at the Woods Hole Oceanographic Institution recorded an unprecedented temporary shift in the Gulf Stream's position. For several weeks, the current meandered nearly 100 miles off its normal course before gradually returning. Scientists were baffled. Nothing in their models had predicted such behavior. Then in 2018, another more dramatic shift occurred. The current appeared to fracture into multiple streams in the mid-Atlantic, with significant portions of warm water diverting southward rather than continuing toward Europe. These anomalies have only grown more frequent and pronounced in subsequent years. Satellite measurements of sea surface heights, which can track the movement of major currents, show increasing variability and decreased flow strength. Temperature probes throughout the Atlantic confirm that the normal heat distribution patterns are changing. Something fundamental is happening to one of Earth's most important ocean currents, and the scientific community is racing to understand why. The leading explanation involves climate change, particularly the influx of freshwater into the North Atlantic from melting Arctic ice and increased rainfall. Remember that the Gulf Stream circulation depends on a delicate balance of temperature and salinity. As water flows northward and cools, it becomes denser and sinks. But freshwater is less dense than salt water. So when large amounts of freshwater enter the system from melting Greenland ice sheets or enhanced precipitation, it can prevent this crucial sinking process from occurring properly. Think of it like trying to sink a cork in water. The density difference makes it nearly impossible. When the normal sinking of cold, salty water in the North Atlantic is disrupted, the entire circulatory system can weaken or even temporarily collapse. Computer models suggest we may be approaching a tipping point where the Gulf Stream could dramatically reorganize or even shut down entirely, though most scientists believe a complete collapse is unlikely in the immediate future. But climate change isn't the only possible explanation for the Gulf Stream anomalies. Some researchers point to natural cyclical patterns that operate on decades-long timescales. The Atlantic multidecadal oscillation, for instance, represents natural variations in North Atlantic sea surface temperatures that occur over 40 to 70-year periods. Perhaps what we're witnessing isn't unprecedented, but simply part of a natural cycle that our modern instruments are detecting for the first time. Others suggest more exotic possibilities. Changes in Earth's magnetic field, which has been weakening in recent decades, might influence ocean currents in ways we don't fully understand. Some researchers have even proposed that shifts in gravitational forces resulting from changes in ice mass distribution could subtly alter ocean circulation patterns. While these explanations remain far more speculative, they highlight how much we still have to learn about the complex, interconnected systems that regulate our planet. What makes the Gulf Stream anomaly particularly mysterious is the speed of the changes. Historical and paleoclimatic records show that major shifts in ocean circulation typically unfold over centuries or millennia, not decades. The rapid pace of the current transformation suggests either that our understanding of these systems is incomplete or that some unprecedented forcing mechanism is at work. The implications of a significantly altered Gulf Stream are profound and potentially far-reaching. Climate models suggest that Western Europe could experience dramatically colder winters, with average temperatures dropping by several degrees in countries that have built their infrastructure around relatively mild conditions. Paradoxically, a weakened Gulf Stream could actually accelerate global warming in other regions by disrupting heat distribution patterns across the planet. Marine ecosystems would face massive disruption. The Gulf Stream creates thermal boundaries that determine the distribution of countless marine species, from microscopic plankton to commercial fish stocks to marine mammals. A shifting current could trigger ecosystem collapses in some areas while creating new habitats in others, reshuffling ocean biodiversity in unpredictable ways. Weather patterns would change dramatically across the northern hemisphere. The Gulf Stream helps drive atmospheric circulation, influencing everything from hurricane formation in the Caribbean to rainfall patterns in Europe and North Africa. A destabilized current could lead to more extreme weather events, prolonged droughts in some regions, and unprecedented flooding in others. Perhaps most concerning is the possibility of rapid, nonlinear changes. Complex systems like ocean currents don't always change gradually. They can maintain apparent stability until reaching a critical threshold, then undergo sudden, dramatic reorganization. Paleoclimate records show evidence of past abrupt shifts in Atlantic circulation that occurred within decades, triggering climate changes that persisted for centuries. Scientists are working urgently to improve our understanding of what's happening. Networks of autonomous floating sensors called Argo floats continuously monitor ocean conditions throughout the Atlantic. The Rapid Array, a system of instruments stretched across the ocean at 26 degrees north latitude, provides real-time measurements of the Gulf Stream's flow, and increasingly sophisticated computer models attempt to predict how the system might evolve in coming decades. Yet despite these efforts, significant uncertainties remain. The ocean is vast and difficult to monitor comprehensively. Our historical records of deep ocean conditions extend back only a few decades, a mere blink of an eye in geological terms. And the complex interactions between oceans, atmosphere, and ice sheets create feedback loops that even our most advanced models struggle to capture accurately. What we do know is that the Gulf Stream is changing, and those changes appear to be accelerating. Whether these shifts represent a temporary anomaly, a new stable state, or the beginning of a more dramatic transformation remains one of the most pressing questions in climate science. The answer could shape the future of human civilization in profound ways, affecting everything from food production to energy consumption to the habitability of entire regions. As we continue to monitor and study this mysterious ocean current anomaly, one thing becomes increasingly clear. The natural systems we've long taken for granted are more fragile and changeable than we once believed. The Gulf Stream's shifting behavior serves as a humbling reminder that for all our technological prowess, we remain at the mercy of planetary forces that we're only beginning to understand. What other crucial Earth systems might be approaching similar tipping points? And how can we prepare for a future where the constants we've built our world around prove to be anything but constant? Of all the mysteries that haunt the world's oceans, few are as deeply unsettling as the fate of the SS Orang Medan. The story reads like something from a horror novel, a ghost ship drifting silently through the Straits of Malacca, its entire crew deceased, their faces frozen in expressions of absolute terror, with no visible signs of injury or struggle. No disease, no wounds, nothing to explain how an entire ship's complement could perish simultaneously. And then, as rescue teams prepared to tow the vessel to port, the Orang Medan erupted into flames and sank to the bottom of the ocean, taking its secrets to the depths. Did it really happen? And if so, what killed everyone aboard? Let's dive into one of the most chilling maritime mysteries of the 20th century. The story begins in June 1947, though some accounts place the incident in February 1948. According to the most widely circulated version of events, several ships sailing through the Straits of Malacca, the busy shipping lane between Sumatra and Malaysia, received a disturbing distress call. The message, transmitted in Morse code, was fragmented but clear enough to send chills down the spines of radio operators who received it. All officers, including captain, are dead, lying in chartroom and bridge, possibly whole crew dead. This was followed by an incomprehensible burst of Morse code, then the harrowing final words, "I die," and then silence. American and Dutch ships in the vicinity, including the Silver Star, reportedly changed course to locate the vessel in distress. After hours of searching, they found the Orang Medan adrift on calm seas, showing no obvious signs of damage or distress from a distance. But when rescue parties boarded the silent vessel, they encountered a scene of inexplicable horror. According to witness accounts, bodies were strewn across the decks and throughout the ship's interior. Every crew member was dead, their eyes wide open, mouths agape in frozen expressions of terror, many with arms outstretched as if warding off an unseen attacker. Even the ship's dog was reportedly found dead, its teeth bared in a final snarl. Most disturbing of all, there were no visible wounds, no signs of violence or struggle, no indication of what could have killed them all. The boarding party reported that the bodies felt unusually warm to the touch despite having been dead for some time, and that an unnatural chill permeated the ship despite the tropical heat. As they prepared to attach a tow line to bring the Orang Medan to port for investigation, smoke began billowing from the cargo holds. The boarding party had barely enough time to evacuate before a massive explosion tore through the vessel, causing it to sink rapidly and disappear beneath the waves, taking any evidence with it. This is the story as it has been told and retold in books, articles, and documentaries about maritime mysteries. It's a perfect ghost ship tale, complete with unexplained deaths, a mysterious cargo, and the convenient destruction of evidence. But here's where our mystery deepens further. There's significant doubt about whether the Orang Medan ever actually existed. Researchers trying to verify the incident have encountered numerous problems. No official records of a vessel named Orang Medan have been found in Lloyd's shipping registers or other maritime databases from the era. The Silver Star, the vessel that supposedly led the rescue attempt, did exist, but shipping records don't place it in the Straits of Malacca during the time frame of the alleged incident. Even more telling, there are no contemporary newspaper accounts or official reports documenting such a dramatic maritime disaster, which would have certainly attracted significant attention. The earliest known printed reference to the Orang Medan appears in a 1952 issue of the Proceedings of the Merchant Marine Council, published by the United States Coast Guard. Even there, it's presented as an unverified account. The story gained wider circulation through a series of Dutch-Indonesian newspaper articles in the early 1950s and was further popularized in a 1962 book called Das Totenskip in der Südsee, The Death Ship in the South Seas, by German author Otto Mielke. So we're faced with a fascinating conundrum. Either one of the most bizarre maritime disasters in history occurred and was somehow omitted from official records, or the entire story is an elaborate legend that has been accepted as fact through repetition. But even if we accept that something did happen to a vessel in the Straits of Malacca, regardless of its actual name, the central mystery remains. What could kill an entire crew without leaving a mark? Over the decades, numerous theories have been proposed. The most scientifically plausible involves carbon monoxide poisoning. Ships of that era often had problematic ventilation systems, and a malfunction in the boiler or exhaust system could have flooded the vessel with odorless, colorless carbon monoxide gas. This could explain the crew's expressions of terror, as they would have experienced confusion, panic, and suffocation before death. It might also account for the reported warmth of the bodies, as carbon monoxide victims often exhibit elevated body temperatures. Others have suggested exposure to nerve agents or other chemical weapons. In the aftermath of World War II, there were rumors of secret military operations to dispose of captured Japanese chemical weapons. Perhaps the Orang Medan was secretly transporting such materials, and a leak in the cargo hold exposed the crew to deadly substances. This theory gained traction with the revelation that many vessels in the region were involved in clandestine transportation of hazardous materials during this period. A related theory involves smuggled chemical compounds. Some researchers have suggested that the ship might have been carrying improperly stored nitroglycerine or other unstable chemicals. These could have released toxic fumes that killed the crew, and later caused the explosion that sank the ship. The illegal nature of such cargo would explain the absence of official records and the subsequent cover-up of the incident. More exotic explanations have been offered as well. Some have suggested that unusual weather phenomena created a pocket of methane gas that rose from the ocean floor and enveloped the ship, suffocating everyone aboard before dissipating. Others point to the possibility of infrasound, extremely low-frequency sound waves that can cause feelings of fear, anxiety, and in extreme cases, internal organ damage. Certain ocean conditions can theoretically generate infrasound waves powerful enough to affect human physiology. Then there are the truly fringe theories, everything from paranormal encounters to extraterrestrial intervention. The expressions of terror on the faces of the dead have fueled speculation about encounters with forces beyond human understanding. Some ufologists have even suggested that the crew witnessed something so beyond comprehension that the experience itself proved fatal. While such explanations lack scientific merit, they speak to the powerful grip this mystery has on our imagination. But perhaps the most interesting aspect of the Orang Medan mystery is what it reveals about how maritime legends form and perpetuate. The shipping lanes of Southeast Asia have long been fertile ground for tales of mystery and horror. The region's complex history of piracy, smuggling, and naval warfare created an atmosphere where unusual disappearances or disasters were not uncommon. The time frame is significant as well. The years immediately following World War II were characterized by considerable chaos in international shipping. Record-keeping was inconsistent. Many vessels were repurposed from military to civilian use with minimal documentation, and the waters around Indonesia were particularly chaotic as the Dutch East Indies transitioned toward independence. In this context, it's entirely possible that a maritime disaster could have occurred without generating official records, especially if clandestine activities were involved. The persistence of the Orang Medan story might also reflect deeper cultural anxieties about technology and the sea. The mid-20th century saw rapid advances in shipping technology and a boom in maritime trade, but also growing awareness of the new dangers. These developments brought chemical pollution, radioactive materials, and other hazards unfamiliar to previous generations of sailors. The image of an entire crew struck down by an invisible, unexplainable force speaks to these modern fears in a powerful way. Whether the Orang Medan ever actually existed or not, its story has become one of the most enduring maritime mysteries of the modern age. Like the Mary Celeste before it, it represents our fascination with the unexplained at sea. The possibility that even in our technological era, the vast oceans can still harbor secrets and dangers beyond our understanding. If the vessel did exist and the events occurred roughly as described, then somewhere on the ocean floor lie the remains of a ship that might contain answers to what can only be described as a perfect maritime mystery. If it never existed, then we're left with an equally fascinating question. How did such a detailed and specific legend emerge and come to be accepted as historical fact by so many? Either way, the tale of the Orang Medan serves as a reminder that the world's oceans, despite all our efforts to chart, monitor, and understand them, remain places of mystery and danger, where ships and their crews can still vanish without explanation, leaving behind only questions and chilling stories that continue to haunt our collective imagination. On December 5, 1945, just months after the end of World War II, 5 United States Navy Avenger torpedo bombers took off from the Naval Air Station at Fort Lauderdale, Florida. Designated as Flight 19, the mission was supposed to be a routine training exercise, a 3-hour navigation drill over the Atlantic Ocean. Led by experienced flight instructor Lieutenant Charles Taylor, the 5 planes carried 14 men, all trained pilots or crew. It should have been entirely unremarkable, just one of many training flights conducted that day. Instead, it became one of the most enduring aviation mysteries of all time. 2 hours into the mission, something went terribly wrong. Radio operators at the base began receiving confused and increasingly desperate messages from Flight 19. Lieutenant Taylor's voice crackled over the radio. "We don't know where we are. We seem to be lost." Then later, "We can't be sure of any direction. Everything is wrong. Strange. Even the ocean doesn't look as it should." The last transmission received from the flight came at 5:42 p.m., fragmented and difficult to interpret. After that silence, Flight 19 had vanished, seemingly into thin air. What makes this disappearance particularly baffling is that extensive search and rescue operations found absolutely nothing. No oil slicks, no debris, no bodies, no sign that 5 large military aircraft had gone down in the waters off Florida's coast. Even more disturbing, one of the search planes sent to find Flight 19, a Martin Mariner flying boat with a 13-man crew, also disappeared during the operation. Unlike Flight 19, witnesses reported seeing this aircraft explode midair and crash into the ocean, yet subsequent searches failed to find any wreckage from this plane either. In total, 27 men and 6 aircraft vanished that day, in what would become one of the most famous incidents associated with the area known as the Bermuda Triangle. But what really happened to Flight 19? Could experienced military pilots simply get lost over familiar waters on a clear day? And how could aircraft seemingly vanish without a trace? The official Navy investigation concluded that Flight 19 most likely went down due to navigational error and fuel exhaustion. According to the report, Lieutenant Taylor had become disoriented and mistakenly believed he was flying over the Florida Keys when, in fact, the flight was somewhere over the Bahamas. This confusion led him to direct his squadron further out to sea rather than toward land, until their fuel ran out and they were forced to ditch in rough ocean waters far from shore. But this explanation has never fully satisfied those who have examined the case closely. Several aspects of the disappearance remain difficult to explain through conventional means. First, these were not inexperienced pilots. While some of the crews were trainees, Flight 19 was led by Lieutenant Taylor, who had logged over 2,500 flight hours, much of it over the very waters they were navigating. Though he had been transferred to Fort Lauderdale recently, Taylor had extensive experience flying in the Pacific Theater during World War II. How could such an experienced aviator become so completely disoriented in familiar airspace? Second, the aircraft were equipped with 2-way radios and standard navigation equipment. While not as sophisticated as modern avionics, these instruments were reliable and well understood. The flight also took place in daylight hours on a day with reported visibility of 20 to 50 miles, conditions that should have allowed the pilots to maintain visual orientation with the coastline. Even if their compasses had malfunctioned, as Lieutenant Taylor seemed to suggest in one transmission, experienced pilots had other means to determine direction, including observing the position of the sun. Third, and perhaps most baffling, is the complete absence of wreckage. The 5 Avenger torpedo bombers were substantial aircraft, each weighing around 7 tons when fully loaded. If they ditched in the ocean, they should have left considerable floating debris. Yet despite one of the largest air and sea searches in naval history, covering more than 250,000 square miles of ocean, not a single piece of wreckage, no life jackets, no oil slicks, nothing whatsoever was found. Over the decades, numerous theories have been proposed to explain the disappearance. The most mundane suggestions focus on human error and natural phenomena. Perhaps Taylor, despite his experience, became fixated on a wrong heading and led his flight out over the open Atlantic until they ran out of fuel. This phenomenon, known as get-homeitis, or plan continuation bias, has been documented in numerous aviation incidents where pilots persist with their original flight plan despite evidence they should change course. Others have pointed to the notoriously treacherous weather of the region. While reports indicated clear conditions at takeoff, the Florida coast is known for rapidly forming thunderstorms and waterspouts that can develop with little warning. Perhaps Flight 19 encountered a violent storm cell that scattered the aircraft and damaged their radio equipment before they could report their situation. The Gulf Stream, which flows through the region, could have quickly dispersed any wreckage over a vast area, making it nearly impossible for searchers to locate evidence of a crash. The depth of the ocean in parts of the search area exceeds 6,000 feet, presenting significant challenges for recovery operations, especially with the technology available in 1945. But these conventional explanations have never quite satisfied the public imagination, and more exotic theories have emerged over the years. The disappearance occurred in the region later popularized as the Bermuda Triangle, a roughly triangular area of ocean between Miami, Bermuda, and Puerto Rico that has allegedly claimed numerous ships and aircraft under mysterious circumstances. Some have suggested that magnetic anomalies in the area might have caused compass malfunctions, disorienting the pilots. Taylor's radio transmissions indicating that everything is wrong and his compasses were not functioning properly lend some credence to this idea. The region does have some unusual magnetic properties, including one of the few places on Earth where magnetic north and true north align exactly. But most scientists dismiss the notion that these variations could cause catastrophic navigational failures in properly equipped aircraft. More speculative theories invoke everything from massive methane gas bubbles erupting from the ocean floor, potentially affecting the density of air and water, to temporary rifts in space-time, or even extraterrestrial intervention. While these explanations lack scientific support, they speak to the profound mystery that continues to surround the case. In 1991, 5 Avenger aircraft were discovered by deep-sea explorers on the ocean floor off the coast of Florida, briefly reigniting interest in the Flight 19 mystery. However, subsequent investigation revealed these planes to be from different training accidents, not the missing squadron. To this day, no confirmed wreckage from Flight 19 has ever been recovered. The disappearance has left an indelible mark on popular culture. It featured prominently in Charles Berlitz's 1974 bestseller, The Bermuda Triangle, which sold over 20 million copies worldwide and firmly established the region's reputation as a place of supernatural mystery. Steven Spielberg's 1977 film, Close Encounters of the Third Kind, incorporated the Flight 19 story, depicting the missing aviators as having been abducted by aliens. Documentaries, books, and television shows continue to explore the disappearance, ensuring that new generations become familiar with the enduring mystery. What makes the Flight 19 case so compelling is not just what happened, but when and where it occurred. The disappearance took place in peacetime, in daylight, in American territorial waters, with multiple aircraft simultaneously, and at a time when the United States possessed unprecedented air and sea rescue capabilities after years of wartime operations. If such a disappearance could happen under these conditions, what might occur in more remote regions, under more challenging circumstances? The timing is particularly significant. December 1945 marked the dawn of a new era. World War II had just ended, and America stood at the beginning of what would become known as the Atomic Age. New technologies were transforming transportation, communication, and warfare. Yet despite these advances, Flight 19 demonstrated that humans could still vanish without a trace, even with the full might of the world's most powerful navy searching for them. It was a humbling reminder of the limits of human knowledge and control. For the families of the 27 men lost that day, the mystery of Flight 19 isn't an entertaining puzzle or fodder for supernatural speculation. It represents a profound personal tragedy and an unhealed wound. Many went to their graves never knowing what happened to their loved ones. No funerals with remains, no definitive answers, just an enduring uncertainty that denies closure. The Naval Air Station in Fort Lauderdale, where Flight 19 departed now, houses a museum with a memorial to the lost airmen. The simple plaque acknowledges both the historical significance of the event and its human cost. They flew from this field never to return, lost with all hands, but they are not forgotten. Perhaps the most sobering aspect of the Flight 19 mystery is that similar disappearances continue to occur in our modern era, despite vastly improved technology. As recently as 2013, Malaysia Airlines Flight 370 vanished with 239 people aboard, leaving few traces despite a multinational search effort using satellites, aircraft, ships, and submarines. Like Flight 19, it serves as a reminder that even in an age of global positioning systems, radar tracking, and instant communications, the vastness of our planet's oceans can still swallow aircraft and ships without revealing their fate. Whether Flight 19 fell victim to conventional difficulties like navigational error and bad weather, or something more mysterious, the case remains unsolved. The complete absence of wreckage despite an extensive search continues to perplex investigators and researchers alike. Perhaps somewhere in the vast depths of the Atlantic Ocean lie the answers, entombed with the aircraft and their crews in the crushing darkness of the deep sea. The disappearance of Flight 19 stands as a stark reminder that even in our modern world of advanced technology and global surveillance, the ocean remains an unpredictable and sometimes unforgiving realm. Its vastness can conceal secrets for decades, even centuries, challenging our belief that we have mastered our environment. What happened to those 14 airmen on that December afternoon continues to haunt maritime and aviation history, a ghostly formation still flying through the mists of speculation and uncertainty, forever lost in the boundaries between known science and unexplained mystery. As technology advances, there remains hope that the wreckage might someday be located, allowing the final chapter of this story to be written. Until then, Flight 19 will continue to symbolize one of the most enduring questions about the Bermuda Triangle and the ocean's capacity to make things vanish without a trace. Were they victims of mundane circumstances, or did they encounter something beyond our understanding? The silence from the deep provides no answers, only the endless whisper of waves that have kept their secret for over 7 decades. Beneath the ocean surface, hidden from human eyes, lies one of nature's most awe-inspiring and mysterious forces, submarine volcanoes. While we're familiar with their terrestrial cousins, these underwater infernos remain largely unexplored, shrouded in darkness and extreme pressure, creating phenomena that sometimes defy our scientific understanding. These hidden volcanic realms make up one of Earth's last great frontiers, a place where water and fire engage in an eternal dance that shapes our planet in ways we're only beginning to comprehend. Imagine standing on the deck of a research vessel in the middle of the Pacific Ocean. The water around you suddenly begins to churn and bubble as if it were being heated from below. The sea takes on strange colors, vibrant greens, unusual blues, or murky browns replacing the familiar deep blue. Fish begin floating to the surface, some dead, others disoriented. The air fills with the pungent smell of sulfur and other volcanic gases. You're witnessing something rare and spectacular, a submarine volcano in the midst of an eruption. What makes submarine volcanoes so enigmatic is their hidden nature. Unlike terrestrial volcanoes that dramatically spew lava and ash into the sky, submarine eruptions often occur without anyone even noticing. Scientists estimate there could be as many as 1 million submarine volcanoes scattered across the ocean floor. Of these, only a small fraction, perhaps less than 1%, have been studied or even properly mapped. They're like phantom mountains, some towering thousands of feet from the seafloor, yet remaining completely invisible from the surface. The West Mata volcano in the South Pacific offers a perfect example of how these hidden giants can surprise us. In 2009, oceanographers captured the first-ever video footage of a deep-sea eruption at West Mata. What they witnessed challenged existing theories about underwater volcanic activity. Instead of slow-moving lava flows, they observed explosive eruptions occurring at depths of nearly 1 mile beneath the surface, something scientists had previously thought impossible due to the enormous pressure at such depths. The footage revealed molten lava exploding into the frigid seawater in a violent display that researchers described as violent, energetic, and fascinating. These observations forced volcanologists to reconsider fundamental assumptions about how submarine eruptions behave. If our theories about something as basic as how lava interacts with water under pressure could be so wrong, what else might we be missing about these underwater giants? Perhaps the most perplexing aspect of submarine volcanoes is their ability to create what sailors have described for centuries as boiling seas. Historical maritime records contain numerous accounts of ships encountering patches of ocean that seem to be boiling, complete with steam rising from the surface and water too hot to touch. Some of these accounts were dismissed as tall tales or exaggerations, until modern science confirmed they were entirely possible. In 2012, passengers aboard a tourist boat near the Canary Islands witnessed the sea beginning to bubble violently. The water temperature rose dramatically, and dead fish floated to the surface by the hundreds. Scientists later confirmed that an underwater volcano called El Hierro had erupted, releasing enormous amounts of heat and volcanic gases that temporarily transformed the surface waters into a hostile environment. What's particularly strange about these events is how localized they can be. A ship might pass through waters that are literally boiling, only to find normal conditions just a few hundred yards away. These submarine eruptions can create other phenomena that seem to defy explanation. Floating stones have been reported throughout history, pumice rocks ejected from underwater volcanoes that are filled with air pockets, allowing them to float across the ocean surface like strange, gray icebergs. After major submarine eruptions, these pumice rafts can cover thousands of square miles of ocean and drift for years before finally becoming waterlogged and sinking. In 2019, sailors in the South Pacific encountered a pumice raft larger than Manhattan, roughly 6 square miles of floating volcanic rock drifting across the open ocean. What made this particularly mysterious was that scientists couldn't immediately identify which underwater volcano had created it. Somewhere beneath the waves, a massive eruption had occurred without detection, powerful enough to expel millions of tons of rock, yet somehow remaining hidden from our global monitoring systems. Even more baffling are the connections between submarine volcanoes and other oceanic mysteries. Some researchers have proposed links between underwater eruptions and the formation of certain types of rogue waves, massive, unexpected wave formations that seem to appear out of nowhere in otherwise calm seas. The sudden release of heat and gas from a submarine eruption could theoretically create pressure differentials in the water column capable of generating unusual wave patterns at the surface. There's also the strange phenomenon of milky seas, rare occurrences where vast stretches of ocean glow with an eerie, uniform white light at night, sometimes covering areas larger than small countries. While bioluminescent bacteria are the immediate cause of this light, some scientists have suggested that submarine volcanic activity might trigger the massive bacterial blooms responsible, by releasing nutrients and changing water chemistry in ways that create perfect conditions for these microorganisms to flourish. The relationship between submarine volcanoes and marine life creates additional mysteries. Areas around underwater volcanic vents often host thriving ecosystems that shouldn't exist at all, communities of creatures living in water hot enough to cook seafood, saturated with toxic chemicals, and completely devoid of sunlight. These hydrothermal vent ecosystems were only discovered in the late 1970s, fundamentally changing our understanding of where and how life can exist. But perhaps the greatest mystery surrounding submarine volcanoes is their potential role in global climate patterns. When major terrestrial volcanoes erupt, they can inject ash and gases high into the atmosphere, sometimes causing temporary cooling effects across the planet. But what happens when equally massive eruptions occur beneath the ocean surface? The water filters out the ash and traps many of the gases, but not all of them. Some still reach the atmosphere, while others dissolve into the ocean itself, potentially altering its chemistry on scales we're only beginning to understand. In 2008, scientists discovered that a massive underwater eruption near Tonga had fertilized a vast area of the South Pacific with iron, triggering an enormous bloom of phytoplankton visible from space. These tiny marine plants absorbed large amounts of carbon dioxide from the atmosphere during their brief lives. When they died and sank to the ocean floor, they took that carbon with them, essentially removing it from the atmosphere. This raises profound questions about whether submarine volcanoes might actually play a significant and previously unrecognized role in regulating Earth's climate over long time scales. What's particularly unsettling is that we know so little about when and where these underwater eruptions might occur. Our monitoring systems cover only a tiny fraction of the seafloor, and many submarine volcanoes remain completely uncharted. A massive underwater eruption could be happening right now in some remote corner of the ocean, and we might never know unless it happens to affect surface conditions in a way that catches someone's attention. Some of the world's largest submarine volcanoes haven't erupted in recorded history, meaning we have no idea what to expect when they eventually do. Massive underwater features like Tamu Massif in the Pacific, a submarine volcano so large that until recently, scientists thought it might be multiple volcanoes clustered together, remain mysterious in terms of their eruptive potential and cycles. Adding to the mystery is the discovery that some submarine volcanoes seem to operate on completely different timescales than their terrestrial counterparts. While land volcanoes might build pressure for decades or centuries before erupting, some underwater volcanoes appear to follow different patterns. The axial seamount off the coast of Oregon has been erupting with surprising regularity, approximately every 5 to 10 years, a pattern rarely seen in terrestrial volcanoes of similar size. What other patterns might be occurring beneath the waves, unnoticed and unrecorded? What cycles of fire and water have been playing out for millions of years, affecting ocean currents, marine life, and possibly even global climate in ways we've yet to recognize? These questions remain largely unanswered, pointing to how little we truly understand about the dynamic processes occurring across 70% of our planet's surface. As technology improves, allowing us to explore deeper and monitor more effectively, we may begin to unravel some of these submarine secrets. But for now, submarine volcanoes remain one of the ocean's most profound enigmas, a reminder that even in our age of satellites and sensors, nature still holds mysteries that lie just beyond our reach, hiding beneath the waves, occasionally making their presence known through boiling seas, floating stones, and other phenomena that continue to challenge our understanding of the world beneath the water. There's something almost dreamlike about walking along a beach and suddenly finding it transformed into a landscape that seems borrowed from another world. Mountains of white foam, sometimes towering several feet high, roll across the sand like strange snow drifts, engulfing everything in their path. These massive foam events have captivated and confused coastal communities for centuries, appearing seemingly out of nowhere to blanket shores, streets, and sometimes entire towns in a mysterious frothy substance that defies easy explanation. What causes these bizarre sea foam events, and why do they sometimes reach such extraordinary proportions? The answer lies at the intersection of biology, chemistry, and oceanography. But even today, aspects of this phenomenon continue to puzzle scientists. Sea foam, at its most basic level, forms when organic matter dissolved in seawater is agitated by wave action, wind, or currents. This creates tiny air bubbles that persist on the surface, accumulating into the frothy substance we recognize as foam. It's similar to what happens when you shake a bottle of soapy water. The agitation incorporates air into the liquid, creating bubbles that, due to the presence of surfactants, don't immediately pop. In the ocean, these natural surfactants come from a variety of sources, including proteins and fats released by decomposing algae, seaweed, and other marine organisms. But this simple explanation fails to account for the truly massive foam events that occasionally transform coastlines around the world. In some cases, foam has been reported reaching heights of over 20 feet, engulfing entire beachfront properties and flowing inland for hundreds of yards. During particularly severe events, coastal roads have become impassable, buried under walls of foam that move like slow-motion avalanches. In towns like Yamba in Australia and Cleveleys in England, residents have awakened to find their communities transformed into surreal landscapes, with buildings and vehicles half buried in undulating masses of white foam. What makes these extreme foam events so mysterious is their unpredictability and their scale. While small amounts of sea foam are common along many coastlines, especially after storms, the truly massive foam events seem to require a perfect convergence of factors that scientists are still working to fully understand. Some of the largest foam events in history have occurred with little warning, catching coastal communities completely by surprise. One of the main contributors to extraordinary foam events appears to be algal blooms, rapid increases in algae populations that can cover vast areas of ocean. When these blooms die off, they release large amounts of organic matter into the water. But not all algal blooms lead to massive foam events, and sometimes foam appears in locations where no significant bloom has been detected. This suggests that other factors must be involved, perhaps specific types of algae, particular oceanic conditions, or even the presence of certain bacteria that help break down the organic matter in ways that promote foam formation. The composition of sea foam itself varies widely, adding another layer to the mystery. While most sea foam is harmless, essentially just salt water mixed with natural organic compounds, some foam events have been associated with strange odors, unusual colors, and even toxic properties. In 2007, a massive foam event along the coast of New South Wales, Australia, was found to contain high levels of pollutants and sewage, likely washed into the ocean during heavy rains. Yet other equally massive foam events have been tested and found to contain nothing more dangerous than the natural byproducts of marine algae. Perhaps the most puzzling aspect of sea foam phenomena is what causes certain foam events to persist for days or even weeks, while others dissipate within hours. Typically, foam bubbles pop relatively quickly as the water between the bubble walls drains out due to gravity, causing the structure to collapse. But during major foam events, the foam can demonstrate remarkable stability, withstanding rain, changing tides, and even moderate winds without dissipating. Some researchers believe this unusual stability might be linked to the specific molecular structures of the organic compounds involved, which create stronger bubble walls than typical surfactants. The weather conditions surrounding major foam events add another dimension to the mystery. While rough seas certainly contribute to foam formation by providing the necessary agitation, some of the most spectacular foam events have occurred after storms have passed, when seas are relatively calmer. In these cases, something about the combination of recent turbulence and subsequent conditions seems to create the perfect environment for foam production and accumulation. Adding to the enigmatic nature of sea foam is its sometimes bizarre behavior. During strong winds, foam can be lifted off the water's surface and blown inland in what witnesses have described as foam storms. Surreal weather events where instead of rain or snow, the air fills with flying globs of white foam. In some cases, these foam storms have reduced visibility to near zero and covered inland areas up to a mile from the coast in a layer of sticky marine residue. Indigenous coastal communities around the world have their own explanations for massive foam events, often linking them to the moods of sea deities or interpreting them as omens. Some traditions view sea foam as the physical manifestation of the ocean's emotions, its way of expressing turbulence or distress. These cultural interpretations speak to how striking and otherworldly these foam events can appear, seeming to transcend ordinary natural processes. Scientists have observed that major foam events often coincide with shifts in ocean chemistry or temperature, raising questions about whether climate change might be influencing their frequency and intensity. Some researchers hypothesize that warming ocean temperatures could be promoting different types of algal blooms or altering the decomposition processes of marine organic matter in ways that enhance foam production. However, the historical record of major foam events is spotty at best, making it difficult to determine whether they're actually becoming more common or simply better documented in our media-saturated age. What's particularly intriguing is how localized massive foam events can be. One beach might be completely engulfed in foam towering several feet high, while a neighboring beach just a few miles away remains completely foam-free. This suggests that very specific local conditions, perhaps related to underwater topography, current patterns, or even the microbiome of that particular stretch of coast, play crucial roles in determining where and when massive foam accumulations will occur. The relationship between sea foam and marine life creates additional mysteries. In some cases, sea foam has been associated with mass die-offs of fish and seabirds. During a 2007 foam event in Pacific Grove, California, hundreds of seabirds were found coated in a sticky substance that researchers identified as a protein-rich foam produced by a red tide algal bloom. The foam destroyed the waterproofing of the birds' feathers, leading to hypothermia and drowning. Yet in other cases, marine life seems completely unaffected by even the most extensive foam accumulations, raising questions about what makes certain foam events harmful while others remain benign. Some foam events have been linked to specific types of algae. The algae Phaeocystes globosa, for instance, is known to produce particularly persistent foam when its colonies break down. But even in cases where the biological source of the foam is identified, scientists often struggle to explain why the foam produced is so extraordinarily abundant and stable. It suggests that our understanding of the chemical interactions between organic compounds in seawater remains incomplete. There's also the question of what happens to all that organic material after a major foam event dissipates. Does it return to the ocean, get absorbed into beach ecosystems, or is it carried by winds further inland, potentially affecting soil chemistry and plant life in coastal regions? The ecological impacts of massive foam events remain poorly studied, particularly their long-term effects on coastal environments. Recent research has begun exploring connections between sea foam and atmospheric chemistry, adding yet another dimension to this mystery. As bubbles in sea foam burst, they can eject tiny particles of salt, organic matter, and bacteria into the air. These particles can potentially serve as nuclei for cloud formation, raising the possibility that major foam events might actually influence local weather patterns or contribute to marine aerosol formation in ways we don't fully understand. What makes sea foam particularly fascinating is how it represents the intersection of so many different natural processes, biological life cycles, ocean chemistry, weather patterns, and coastal dynamics all converging to create these strange, ephemeral landscapes of foam. It reminds us that even seemingly simple phenomena can emerge from incredibly complex systems with variables we're still working to understand. The next time you visit a beach and notice a bit of foam gathering at the shoreline, consider that you're observing the mild version of a phenomenon that occasionally transforms entire coastlines into otherworldly landscapes. Somewhere in the intricate dance between microscopic sea life, ocean chemistry, and the physical forces of wind and wave lies the explanation for why, every so often, the boundary between sea and land becomes blurred by mountains of mysterious white foam that seem to defy explanation. Off the coast of North Carolina lies one of the most enduring maritime mysteries of the 20th century, the strange fate of the Carroll A. Deering. This five-masted commercial schooner, built in 1919, was found run aground on the treacherous Diamond Shoals near Cape Hatteras in January 1921. Her crew mysteriously vanished without a trace. No bodies were ever recovered, no definitive explanation was ever established, and the questions surrounding this ghost ship continue to haunt maritime historians and mystery enthusiasts to this day. What happened to the crew of the Carroll A. Deering? The answer seems to be hidden somewhere in the depths of the Atlantic, in what has become known as the graveyard of the Atlantic. The story begins innocently enough. The Carroll A. Deering, a massive wooden schooner stretching 255 feet from bow to stern, departed Boston Harbor in August 1920, bound for Rio de Janeiro with a cargo of coal. Captain William H. Merritt was in command, with his son serving as first mate. Shortly after departure, however, Captain Merritt fell ill, forcing the vessel to put in at Lewes, Delaware, where a replacement captain was needed. This is where Captain Willis B. Wormel enters the story, an experienced mariner in his mid-60s, who would be the last known captain of the ill-fated vessel. After successfully delivering its cargo to Rio de Janeiro, the Deering began its return journey in December 1920, heading back toward its home port in Maine. On January 9, 1921, the ship stopped at Barbados to resupply, and it was here that the first hints of something amiss began to emerge. A man named Christopher Columbus Gray, who was serving as a customs official, later reported that Captain Wormel had mentioned having problems with his crew, particularly the first mate, a man named Charles McClellan. According to some accounts, Wormel confided that he feared the crew might be on the verge of mutiny. Yet when the Deering left Barbados, nothing seemed outwardly wrong. The vessel was spotted passing Cape Lookout Lightship in North Carolina on January 28, 1921, and the lighthouse keeper, Thomas Jacobson, reported a curious sight. A crewman aboard the Deering, who was not dressed like a typical officer, hailed the lightship and reported that the vessel had lost its anchors. This would be the last known human contact with anyone aboard the Carroll A. Deering. 3 days later, on January 31, the schooner was spotted run aground on Diamond Shoals by the Cape Hatteras Coast Guard. Due to rough weather and treacherous sea conditions, rescuers couldn't reach the ship for several days. When they finally boarded the vessel on February 4, they discovered a ghost ship in the truest sense. Not a single soul remained aboard. The navigation equipment and ship's papers were missing, along with the personal belongings of the crew and the ship's lifeboats. In the galley, food appeared to have been prepared for a meal that was never eaten, with plates laid out as if the crew had been interrupted in the middle of their dinner preparations. What makes this case particularly baffling is the condition of the ship itself. Despite being stranded on the shoals, the Carroll A. Deering was largely intact. The sails were set as if for a normal voyage. There were no signs of fire, violence, or natural disaster. It simply appeared as though the entire crew had vanished into thin air in the middle of an ordinary day at sea. All told, 11 men had disappeared without explanation: Captain Wormel, the first mate McClellan, and 9 other crew members. The mystery of the Carol A. Deering quickly captured public imagination and triggered multiple investigations. The U.S. Department of Commerce launched an extensive investigation involving 5 government departments, including the Navy, Coast Guard, Customs, the Department of Justice, and the Commerce Department itself. Such a multi-agency response to a missing crew was unprecedented and speaks to how truly puzzling officials found the case. As investigators delved deeper into the mystery, strange details continued to emerge. A steamer ship called the SS Lake Elon had passed through the same waters shortly before the Deering was discovered. Its captain reported seeing a vessel that matched the Deering's description, sailing in a manner that seemed unusual for a schooner of its size, almost as if being navigated by someone unfamiliar with handling such a vessel. Then came one of the most bizarre aspects of the case. In April 1921, a fisherman discovered a bottle washed up on the shore near where the Deering had grounded. Inside was a message allegedly signed by the ship's mate, stating, "Deering captured by oil-burning boat something like chaser, taking off everything, handcuffing crew. Crew hiding all over ship, no chance to make escape. Finder please notify headquarters Deering." While officials initially took this message seriously, handwriting analysis later suggested it was likely a hoax, adding another layer of confusion to an already perplexing case. Theories about what happened to the Carol A. Deering and her crew have proliferated over the decades, ranging from the plausible to the fantastic. The most conventional explanation suggests that the crew abandoned ship during the severe weather that was reported in the area around that time. Perhaps they feared the vessel was about to break up on the shoals and took to the lifeboats, only to perish in the turbulent seas. This would explain the missing lifeboats, but fails to account for why the crew would abandon a ship that was still in relatively good condition, or why they would leave in the middle of meal preparations. Another prominent theory involves piracy or mutiny. The tensions reportedly brewing between Captain Wormel and his crew, particularly the first mate, have led some to speculate that a mutiny occurred, with the captain and any loyal crew members either killed or forced into lifeboats. Alternatively, the ship might have been attacked by pirates who removed the crew and valuable navigation equipment before abandoning the vessel to drift onto the shoals. The Prohibition era had just begun, creating opportunities for rum running and other illicit maritime activities along the Atlantic coast. Some researchers have pointed to a potential connection with another mystery ship from the same period, the Hewitt, a vessel that disappeared around the same time in the same general area, might have been involved in a collision with the Deering. Perhaps the crews of both ships were rescued by a passing vessel that later sank before reaching port, explaining why no witnesses ever came forward. More fantastic explanations have included supernatural phenomena, alien abduction, and the influence of the so-called Bermuda Triangle, though the Deering was found significantly north of this infamous region. While these explanations lack scientific credibility, they speak to how thoroughly conventional explanations have failed to resolve the mystery. What makes the Carol A. Deering case particularly enduring is how many basic questions remain unanswered after a century. If the crew abandoned ship, why were there no distress signals? If there was a mutiny, what happened to both the mutineers and their victims? If pirates were responsible, why didn't they take the valuable ship itself rather than just the crew and equipment? Each theory seems to explain some aspects of the mystery while leaving others unresolved. The investigation eventually reached the desk of President Warren G. Harding himself, who took a personal interest in the case. Despite deploying significant government resources, including having submarines search the ocean floor for evidence of other wrecks that might have been involved, no conclusive explanation was ever found. In 1922, with all leads exhausted, the investigation was officially closed, leaving the fate of the Carol A. Deering's crew an enduring maritime mystery. The wreck of the Deering itself didn't survive long after its discovery. Salvage efforts were attempted, but proved too difficult in the treacherous waters of Diamond Shoals. Eventually, the ship broke apart in the surf, its timbers scattered or washed away, leaving nothing but stories and speculation behind. What makes this case particularly haunting is how it happened not in some remote, uncharted sea, but in American waters during the age of radio communication and regular shipping traffic. The Diamond Shoals area was well traveled, with lightships, coastal communities, and other vessels frequently passing through. How could 11 men disappear from a massive schooner without someone seeing or hearing something? The silence is perhaps the most disturbing aspect of the entire mystery. Over the decades, the story of the Carol A. Deering has become interwoven with the folklore of North Carolina's Outer Banks, where tales of shipwrecks, pirates, and maritime disasters have accumulated for centuries. Some locals still claim that on stormy nights, the ghostly outline of a five-masted schooner can sometimes be glimpsed off Diamond Shoals, a phantom ship still searching for its lost crew. What happened during those final days of January 1921? Did the crew meet with violence at the hands of pirates or their own shipmates? Were they swept away by an unexpected rogue wave or waterspout? Did they abandon ship only to perish in the notoriously dangerous waters near Cape Hatteras? Or is there some explanation that investigators never considered? A century later, the Carol A. Deering remains one of the most complete ghost ship mysteries in maritime history. A vessel found largely intact, in frequently traversed waters, yet completely abandoned under circumstances that have never been explained. As the Atlantic continues to keep its secrets, the fate of those 11 men remains written only in the depths of the ocean itself, an enduring enigma of the deep. There's something magical about standing on a shoreline and gazing out at the vast expanse of ocean stretching to the horizon. But imagine returning to that same spot the next day to find that the familiar blue waters have inexplicably transformed, perhaps into a striking emerald green, a milky turquoise, or even a rusty red or purple hue that seems entirely alien. This phenomenon, where the color of the sea appears to shift dramatically over short periods of time, has fascinated and puzzled people for centuries. Sometimes these transformations occur gradually over weeks, but in the most mysterious cases, they happen seemingly overnight, as if some vast cosmic artist had changed the entire palette of the seascape while the world slept. What causes these dramatic color shifts, and why do they sometimes happen so suddenly that they seem to defy natural explanation? The ocean's color is primarily determined by how sunlight interacts with water molecules and whatever particles or organisms are suspended within it. Pure water appears blue because it absorbs the longer wavelengths of light, reds and yellows, while scattering the shorter blue wavelengths back to our eyes. But the ocean is rarely pure water. It contains countless dissolved and suspended substances that can dramatically alter how light behaves as it passes through the water column. While scientists understand many of the basic mechanisms behind ocean color, what continues to mystify researchers are the cases where vast stretches of ocean undergo radical color transformations within extremely short timeframes, sometimes literally overnight. These aren't small, localized changes, but shifts that can span hundreds or even thousands of square miles of ocean surface. Even more puzzling are instances where these dramatic color changes occur without obvious environmental triggers like storms or seasonal transitions. One of the most common causes of ocean color shifts is phytoplankton, microscopic plant-like organisms that form the base of marine food chains. When conditions are right, phytoplankton can reproduce explosively, creating what scientists call blooms that may contain billions of organisms per gallon of seawater. Different species of phytoplankton contain different photosynthetic pigments, which can turn the water various shades of green, red, brown, or even purple. What mystifies scientists is not that these blooms occur, but how they can sometimes develop with such extraordinary speed. In 2017, satellite imagery captured a massive bloom forming off the coast of Norway that transformed thousands of square miles of ocean from deep blue to vibrant turquoise in less than 48 hours. Scientists struggled to explain the rapidity of this transformation, as phytoplankton blooms typically develop over days or weeks, not overnight. Some researchers suggested that the organisms might have already been present throughout the water column, but suddenly migrated to the surface in response to changing conditions. Others proposed that certain species might possess reproductive capabilities far exceeding what was previously thought possible. Even more challenging to explain are the sudden appearances of what mariners have long called milky seas, rare phenomena where vast patches of ocean emit an eerie, uniform glow at night. These events, which can cover areas larger than small countries, transform the ocean's color both day and night. During daylight hours, affected areas appear as oddly milky, opaque patches that stand in stark contrast to surrounding waters. The most famous documented case occurred in January 1995, when the British merchant vessel SS Lima reported sailing through a glowing patch of Indian Ocean that stretched as far as the eye could see in all directions. While bioluminescent bacteria are the immediate cause of the glow, the mystery lies in what triggers these bacteria to suddenly proliferate and activate their light-producing capabilities across such vast areas simultaneously. Some scientists have proposed connections to underwater geological events that might release nutrients or change water chemistry, while others suspect complex interactions with other marine microorganisms that remain poorly understood. Red tides represent another color-changing phenomenon that continues to puzzle researchers with their occasionally explosive development. These events occur when certain species of algae bloom in such concentrations that they turn the water various shades of red, orange, or brown. While some red tide events develop gradually, others have been reported to appear almost overnight. In August 2018, a massive red tide appeared along Florida's Gulf Coast, transforming clear blue waters into a reddish-brown murk that stretched for over 150 miles. Residents reported that in some areas, the transformation occurred within hours, with beaches that had been normal in the morning becoming discolored by evening. What makes these sudden color transformations particularly mysterious is that they seem to defy what we know about biological reproduction rates and oceanic mixing processes. Even the fastest reproducing microorganisms typically require certain minimum timeframes to reach bloom concentrations, and ocean currents generally mix and disperse organisms rather than concentrating them. Yet these rapid, large-scale color shifts suggest mechanisms that can overcome these limitations in ways that science hasn't fully explained. Some researchers have proposed that these accelerated color changes might involve organisms that remain dormant in sediments or deeper water layers before being triggered to become active simultaneously across large areas. This could explain the apparent suddenness of some blooms. The organisms were already present but invisible until something caused them to change their behavior or position in the water column. Another hypothesis involves the interaction between physical and biological processes. Oceanic fronts, boundaries between different water masses, can sometimes act as concentration mechanisms, gathering floating organisms along their edges. If these fronts move or develop quickly due to changes in currents or weather patterns, they might create the appearance of an overnight bloom by rapidly concentrating organisms that were previously dispersed across a wider area. Adding to the mystery are reports from maritime traditions around the world that link sudden ocean color changes to seismic activity. Japanese fishermen have long associated certain patterns of water discoloration with impending earthquakes, and similar beliefs exist among coastal communities from Chile to Indonesia. While such connections might initially seem like superstition, recent scientific research has begun to explore possible mechanisms by which submarine geological processes could trigger rapid biological or chemical changes in overlying waters. One theory suggests that underwater seismic events might release trapped pockets of nutrients or gases that could rapidly alter water chemistry and trigger biological responses. Alternatively, subtle temperature changes caused by geothermal activity might create ideal conditions for certain microorganisms to bloom explosively. These potential connections remain largely speculative, but they highlight how little we truly understand about the complex interactions between geological, chemical, and biological processes in the ocean. Perhaps the most bewildering color-changing events are those that defy easy categorization, transformations that don't align with known bloom patterns or recognized oceanographic phenomena. In March 2012, residents of Hangsha Bay in southern China awoke to find their local waters had turned a brilliant crimson overnight. Scientific testing revealed no known algal bloom species in sufficient concentration to explain the color. Similarly, in July 2016, sections of the Daldican River near Russia's Arctic coast suddenly turned bright red, with satellite imagery confirming that the discoloration appeared within a 24-hour period. While industrial pollution was initially suspected, the concentration and rapid appearance of the coloration puzzled environmental scientists. The rapid timescale of these changes is particularly difficult to reconcile with our understanding of how ocean chemistry and biology typically function. Changes in water chemistry generally occur gradually as compounds mix and react, while biological processes like reproduction and growth have their own inherent time limitations. Yet these overnight transformations suggest mechanisms capable of operating much more rapidly than conventional science would predict. Some researchers have begun exploring whether certain threshold effects might be at work, situations where gradual, invisible changes accumulate until reaching a tipping point that triggers a sudden, visible transformation. This could involve chemical reactions that proceed slowly until a critical concentration is reached, at which point they accelerate dramatically, or biological systems that remain in check until a specific environmental trigger removes whatever was limiting their growth or visibility. The role of weather and atmospheric conditions in these sudden color shifts adds another layer of complexity. Changes in wind patterns can rapidly mix water columns, potentially bringing deeply suspended particles or organisms to the surface. Sudden rainfall can alter surface salinity and nutrient levels almost instantaneously across large areas. Even changes in cloud cover and sunlight can dramatically alter how we perceive ocean color by changing the angle and quality of light reflecting off the water's surface. What makes these color-changing events particularly significant is their potential as indicators of ocean health and climate change impacts. As ocean temperatures rise and chemical compositions shift due to human activities, unusual and rapid color changes may become more frequent, serving as visible manifestations of deeper transformations occurring within marine ecosystems. Understanding these phenomena isn't merely an academic exercise. It could provide crucial insights into how our oceans are responding to environmental stressors. Yet despite advances in satellite monitoring, underwater sensors, and marine biology, many aspects of these sudden color transformations remain elusive. The ocean's vastness, combined with the ephemeral nature of some of these events, makes them difficult to study systematically. A color change might appear and disappear before scientists can mobilize the resources needed to investigate it properly, leaving behind only photographs, satellite images, and eyewitness accounts as evidence. In many ways, these mysterious color shifts remind us of how much remains unknown about our oceans. Despite covering more than 70% of our planet's surface, the oceans remain largely unexplored, with vast regions never directly observed by human eyes. We know more about the surface of Mars than we do about much of our own ocean floor. This knowledge gap extends to the complex biochemical and physical processes that can transform the appearance of our seas within remarkably short timeframes. What's particularly fascinating is how these color changes can sometimes serve as windows into hidden oceanic processes that would otherwise remain invisible to us. When a patch of ocean suddenly turns emerald green or milky white, it's revealing something about unseen currents, microscopic life forms, or chemical reactions occurring beneath the surface. These visible transformations are like the ocean's way of communicating its internal dynamics, if only we could fully understand what it's trying to tell us. Historical accounts add another layer of mystery to these color-changing phenomena. Ancient mariners from multiple cultures recorded encounters with waters that changed color dramatically overnight, often attributing these transformations to supernatural causes or the moods of sea deities. While we now understand many of these events in scientific terms, the sense of wonder and mystery they inspire hasn't diminished. There's something profoundly humbling about watching a familiar seascape transform into something entirely different, a reminder of nature's capacity to surprise us even in this age of scientific advancement. Some of the most puzzling color changes defy easy categorization because they combine multiple causes operating simultaneously. A submarine volcanic eruption might trigger both chemical changes in the water and biological responses from marine organisms. Rising temperatures might activate dormant microorganisms, while also altering how light penetrates the water column. The ocean is not a laboratory where variables can be isolated and studied one at a time. It's a complex, interconnected system where countless processes unfold simultaneously, creating effects that can seem almost magical in their suddenness and scale. As our climate continues to change, scientists are watching closely for unusual patterns in ocean color as potential indicators of larger systemic shifts. Satellite monitoring now allows us to track ocean color across the globe, revealing patterns that would have been impossible to detect from ship-based observations alone. These monitoring systems have documented an increase in the frequency and extent of certain types of color-changing events, particularly in warmer waters, raising questions about whether we're witnessing the early stages of fundamental changes in marine ecosystems. Perhaps what makes these color-changing phenomena so captivating is how they remind us that the ocean is not a static, unchanging backdrop to human activity, but a dynamic, living system capable of dramatic transformations. A sea that appears serene and unchanging one day can become something entirely different the next, not through any human intervention, but through its own internal processes, many of which remain mysterious to us despite centuries of scientific inquiry. The next time you find yourself gazing out at the ocean, take a moment to consider that its familiar blue hue is just one of many faces it might wear. Beneath the surface, countless invisible processes are unfolding: chemical reactions, microscopic life cycles, currents and countercurrents, that could, under the right conditions, transform that blue expanse into something entirely different almost overnight. In this age of satellite imagery and advanced oceanography, the ocean still keeps many of its secrets, including exactly how and why it sometimes changes its colors with such dramatic suddenness, leaving us to wonder what other mysteries might still be hidden beneath those ever-changing waves. There are mysteries in our oceans that seem to blur the line between reality and folklore, phenomena that make us question what we know about the natural world. Perhaps none is more haunting than the legend of the phantom shipwreck that supposedly reappears every 25 years off the coast of Cape Hatteras, North Carolina. Known to locals as the Ghost Galleon, this mysterious vessel has been reported by fishermen, Coast Guard officials, and everyday beachgoers for nearly 2 centuries. The story begins in the year 1832, when a Spanish merchant ship called the Isabella Maria vanished during a violent storm while carrying a cargo of gold, silver, and precious artifacts from the New World back to Spain. According to shipping records from the time, The three-masted galleon had a crew of 42 men and was last spotted near the treacherous waters of the Outer Banks, an area so notorious for shipwrecks that it earned the grim nickname, Graveyard of the Atlantic. What makes this particular shipwreck story different from countless others is what allegedly happened 25 years later. In 1857, on the anniversary of the Isabella Maria's disappearance, local fishermen reported seeing the unmistakable silhouette of a Spanish galleon partially submerged in the shallow waters near Diamond Shoals. The witnesses described rotting sails that somehow still caught the wind, and a broken mast that creaked and groaned as if still bearing the weight of a phantom crew. By the time authorities arrived to investigate, the ship had vanished without a trace, no debris, no floating timbers, nothing to suggest a ship had been there at all. The phenomenon might have been dismissed as a collective hallucination or a simple case of mistaken identity, if not for what happened 25 years later. In 1882, the phantom ship reportedly appeared again, this time witnessed by a lighthouse keeper and his assistant. They described the same three-masted galleon, its wood blackened and worn by centuries of salt water, visible for approximately 6 hours before disappearing beneath the waves as the tide changed. The lighthouse keeper, a man named Thomas Harrington, was so disturbed by the sight that he documented it meticulously in his logbook, writing that the vessel seemed to hover between our world and another, as if trapped in time itself. The pattern continued. Reports surfaced in 1907, 1932, 1957, and so on, always spaced exactly 25 years apart, always near the anniversary of the original sinking, and always featuring similar descriptions of a partially submerged Spanish galleon that appears for several hours before vanishing completely. The most well-documented sighting occurred in 1982, when a charter fishing boat with 12 passengers and crew encountered the wreck. The captain, William Mathers, an experienced seaman with 30 years of experience navigating the waters around Cape Hatteras, reported seeing the ship approximately 300 yards from his vessel. What's particularly interesting about this sighting is that multiple people took photographs, though skeptics are quick to point out that the resulting images show only vague, dark shapes in foggy conditions that could easily be misidentified natural formations. Marine archaeologist Dr. Eleanor Parsons from the University of North Carolina has spent decades studying this phenomenon. What makes the ghost galleon of Cape Hatteras so intriguing, she explains, is the consistency of the reports across nearly 2 centuries. The descriptions remain remarkably similar despite being separated by 25-year intervals and coming from witnesses who could not possibly have communicated with one another. So what exactly could explain this recurring apparition? The theories range from scientific to supernatural, each with their own advocates and evidence. The most common explanations fall into 4 main categories, and each raises as many questions as it answers. The first and perhaps most skeptical explanation is that the sightings are simply a case of mistaken identity combined with the power of suggestion. The waters around Cape Hatteras are notoriously treacherous, with constantly shifting sandbanks that have claimed over 500 ships throughout recorded history. What people might be seeing, according to this theory, are simply different wrecks that become temporarily exposed when strong currents or powerful storms shift the sands on the ocean floor. Once people began expecting to see a ghost ship every 25 years, confirmation bias did the rest. They saw what they expected to see. But this explanation fails to account for the remarkable consistency in the descriptions and the precise timing. If it were merely random shipwrecks being revealed by shifting sands, why would they appear at such regular intervals? And why would witnesses separated by generations describe virtually identical vessels? A second, more scientific explanation involves a rare oceanographic phenomenon known as cyclic sedimentation. Some geologists suggest that unique current patterns around Cape Hatteras might cause sand and sediment to build up and erode in predictable cycles. If these cycles happen to occur roughly every 25 years, they could periodically reveal a sunken wreck that remains buried the rest of the time. While this theory has some merit, oceanographers point out that no other location on Earth has documented sediment cycles with such precise timing. The third explanation ventures into more speculative territory, suggesting that what witnesses are seeing is some form of atmospheric phenomenon, perhaps a specific type of mirage caused by unusual temperature gradients over the water. These mirages, known as fata morgana, can distort distant objects beyond recognition, sometimes making them appear to float above the horizon. According to this theory, perhaps something as mundane as a modern fishing vessel or offshore structure is being transformed by atmospheric conditions into what appears to be an ancient galleon. The problem with this explanation is that fata morgana typically occurs in specific weather conditions, not on a rigid 25-year schedule. And while mirages can certainly create strange visual effects, they don't typically maintain the same illusion for hours at a time, especially not to multiple witnesses viewing from different angles. This leaves us with the fourth and most controversial explanation, that what people are witnessing is something truly paranormal. Some paranormal researchers suggest that particularly traumatic events can leave an energetic imprint on a location, creating what's essentially a replay of past events that becomes visible under certain conditions. Others propose even more exotic explanations involving time slips or moments when the barrier between dimensions temporarily thins, allowing objects from other timelines to briefly materialize in our own. Of course, the scientific community generally rejects these paranormal explanations, citing the complete lack of measurable evidence. Yet even the most skeptical researchers admit that the ghost galleon phenomenon has aspects that conventional explanations struggle to address. What adds another layer of intrigue to the mystery is the connection to local indigenous legends. The Croatan people, who inhabited the Outer Banks long before European settlement, had stories of what they called the returning ships, vessels that would appear and disappear with the changing seasons. According to their oral traditions, these ships contained the spirits of those who died at sea, temporarily returning to the world of the living before being called back to the spirit realm. If the pattern holds true, the next appearance of the ghost galleon should occur in 2032, exactly 200 years after the original sinking of the Isabella Maria. Already, paranormal enthusiasts, marine archaeologists, and curious onlookers are making plans to be in Cape Hatteras for the occasion, armed with modern cameras, underwater drones, and sophisticated monitoring equipment. Dr. Parsons, the marine archaeologist we mentioned earlier, has secured funding for what she calls Project Reappearance, a scientific expedition designed to document and study the phenomenon if it occurs again. Whether we're dealing with an actual shipwreck that's periodically revealed by natural processes, an optical illusion, or something we don't yet understand, the ghost galleon deserves serious scientific attention, she says. At the very least, solving this mystery would help us better understand the complex interactions between ocean currents, weather patterns, and underwater archaeology. While many scientists remain skeptical, the legend has become deeply embedded in local culture. The town of Hatteras holds a ghost galleon festival every 25 years, celebrating the mystery with historical reenactments, ghost stories, and scientific discussions. Local tourism thrives during these years, with hotels booked solid months in advance. Perhaps the most compelling aspect of this mystery is how it challenges our understanding of reality itself. In a world where we've mapped every inch of the planet and explained so many once mysterious phenomena, the ghost galleon of Cape Hatteras stands as a reminder that the line between legend and fact isn't always as clear as we might like to believe. Something is happening in those waters every 25 years, something that witnesses insist is real, that photographs suggest is physical, but that somehow eludes definitive explanation. As we continue to explore the depths of our oceans, using increasingly sophisticated technology to unlock their secrets, perhaps we'll finally uncover the truth behind this enduring maritime mystery. Or perhaps, like so many aspects of the sea, it will continue to defy our attempts to categorize and explain it, remaining forever in that tantalizing space between known and unknown, between science and legend, between the world we understand and the deeper mysteries that lie just beyond our comprehension. But the ghost galleon isn't the only ocean mystery that challenges our understanding of the natural world. Some ocean phenomena don't disappear and reappear over decades. They're constantly present, visible reminders of the incredible forces at work beneath the waves. And few are more mesmerizing or more potentially deadly than our next subject, the monstrous whirlpool known as saltströmmen. In the cold waters off the northern coast of Norway, just a few miles from the city of Bodø, lies a narrow strait where nature performs one of its most spectacular and terrifying displays. 4 times a day, like clockwork, the peaceful waters begin to churn and swirl, gradually building into a series of massive whirlpools that can reach up to 10 meters in diameter and 5 meters in depth. The locals call it saltströmmen, the salt stream, but to mariners throughout history, it's been known simply as the maelstrom, a word that has since become synonymous with chaos and destruction. What makes saltströmmen unique isn't just its size or power, but the eerie predictability with which it forms and dissolves. Unlike most natural phenomena that depend on unpredictable factors like weather, saltströmmen operates with almost mechanical precision, driven by the eternal dance between moon, earth, and ocean. Every 6 hours and 13 minutes, as the tide shifts, up to 400 million cubic meters of water, a volume equivalent to 160,000 Olympic swimming pools, forces its way through a narrow channel just 150 meters wide, connecting 2 fjords. The result is the most powerful tidal current in the world, with water speeds reaching 22 miles per hour. As these rushing waters encounter underwater ridges and rock formations, they create vortices powerful enough to drag small boats to their doom. The largest of these whirlpools, known as the Great Eddy, can maintain its terrifying rotation for up to 20 minutes before mysteriously dissolving back into the churning waters, only to reform again with the next tidal shift. The earliest recorded mention of this phenomenon comes from ancient Norse sagas, where it was described as the work of Ran, the goddess of the sea who dragged ships down with her net. According to these legends, the goddess created the whirlpool to capture sailors who had failed to bring her proper offerings before their voyages. The Vikings, who were among history's most accomplished seafarers, treated saltströmmen with extreme caution, timing their journeys carefully to avoid the periods when the maelstrom was at its most powerful. In 1648, the phenomenon gained wider attention when a Norwegian priest named Petter Dass wrote about it in his work, Trumpet of Nordland, describing how the currents here run with such terrible speed that they roar like a bellowing ox. But it was Edgar Allan Poe's 1841 short story, A Descent into the Maelstrom, that truly cemented the saltströmmen in popular imagination, depicting a terrifying whirlpool that was a smooth, shining, and jet-black wall of water, inclined at an angle of some 45 degrees. While Poe took considerable creative liberties in his description, exaggerating both the size and danger of the whirlpool, his story captured something essential about the psychological impact of witnessing such a powerful natural phenomenon. The mixture of terror and fascination that still draws thousands of tourists to saltströmmen each year. The science behind saltströmmen is well understood in principle, though the specific dynamics continue to challenge oceanographers and fluid physicists. The basic mechanism involves the dramatic difference in sea levels between the Saltfjord and the Eskjørsted on either side of the narrow channel. When the tide changes, the water level in one fjord becomes significantly higher than in the other, creating an immense pressure differential that forces water through the strait at tremendous speeds. What makes this particular maelstrom so powerful is a perfect storm of geographic factors. The extreme narrowness of the channel relative to the massive bodies of water it connects, the presence of a shallow underwater threshold that intensifies the current, and the strong tidal variations characteristic of northern latitudes. It's a rare combination that doesn't exist in quite this form anywhere else on Earth. Dr. Helge Avlesen, an oceanographer from the University of Bergen who has spent decades studying tidal phenomena, explains it this way. Imagine trying to empty an Olympic-sized swimming pool through a garden hose in just a few hours. The pressure would be enormous. Now scale that up by a factor of thousands, and you begin to understand what's happening at Saltstraumen. But understanding the general principles doesn't fully explain all the behavior observed at Saltstraumen. One of the most puzzling aspects is the way the whirlpools form and dissipate with such regularity. While computer models can predict when the current will be strongest, they still struggle to accurately simulate the exact patterns of vortex formation, or explain why some tidal cycles produce larger whirlpools than others under seemingly identical conditions. Another mystery involves the strange acoustic properties of the maelstrom. Local fishermen have long reported unusual sounds emanating from the waters during peak flow, not just the expected roar of rushing water, but distinct, almost musical tones that seem to resonate at specific frequencies. Recent scientific expeditions have confirmed these accounts, recording infrasound emissions that don't match typical hydrodynamic noise profiles. Some researchers speculate that these sounds might be created by water interacting with underwater cave systems or hollow rock formations, essentially turning the entire strait into a giant, water-powered pipe organ. Even more intriguing are the reports of bizarre electromagnetic anomalies in the area. Compass needles reportedly spin erratically near the largest whirlpools, and sensitive electronic equipment sometimes malfunctions without explanation. While skeptics attribute these effects to simple human error or equipment failure in harsh conditions, others point to the possible generation of localized electromagnetic fields through the rapid movement of salt water, which is a good electrical conductor, through the Earth's magnetic field. What can't be disputed is the maelstrom's impact on the local ecosystem. Contrary to what one might expect, Saltstraumen isn't a dead zone, but rather one of the richest marine environments in Norway. The powerful currents bring a constant supply of nutrients, creating ideal conditions for plankton, which in turn attracts an extraordinary diversity of life. The area is home to over 120 species of fish, including massive cod, pollock, wolffish, and halibut that grow to sizes rarely seen elsewhere. Local fishermen have developed specialized techniques to fish the maelstrom, timing their efforts to the brief periods between tidal shifts when the water is relatively calm. They tell stories of catching cod weighing over 80 pounds, specimens that seem to thrive in the oxygen-rich, nutrient-dense environment created by the constant churning of waters. These same fishermen also share darker tales of whirlpools suddenly forming where none were expected, of boats being spun in complete circles before being released, and of strange objects being regurgitated from the depths after being swallowed by the vortices. One particularly persistent local legend tells of a 1943 incident during World War II, when a German patrol boat allegedly got caught in the maelstrom during an unusually strong tidal cycle. According to the story, the boat was pulled into one of the largest whirlpools ever witnessed at Saltstraumen and disappeared completely. 3 days later, wreckage from the vessel supposedly washed up more than 20 miles away, with the metal hull twisted and crushed as if it had been subjected to enormous pressure, far greater than would be expected even at the maelstrom's maximum depth. While no official military records confirm this incident, the story illustrates the blend of fact and folklore that surrounds Saltstraumen, as well as the genuine danger posed by this natural phenomenon. Even today, with all our technological advantages and understanding of tidal patterns, several boats get into trouble in the strait each year, requiring rescue by local authorities. For scientists, Saltströmen represents a unique natural laboratory for studying extreme hydrodynamics. Researchers use advanced sonar equipment to map the intricate patterns formed by the currents and employ sophisticated computer models to better understand the complex interactions between water, wind, and the seafloor topography. Some of these studies have practical applications, helping engineers design more efficient tidal power systems or develop safer maritime navigation techniques. Yet despite all this scientific attention, Saltströmen retains an air of mystery. There's something about standing on the shore watching these massive whirlpools form and dissolve that connects us to our ancestors who first gazed upon this same sight thousands of years ago, feeling the same mixture of awe and terror. In an age where few natural phenomena remain unexplained, the sheer visceral power of the world's strongest maelstrom reminds us of nature's capacity to inspire wonder. As impressive as Saltströmen is, however, it's a visible manifestation of the ocean's power, something we can see, photograph, and to some extent predict. But beneath the waves lurk other phenomena that remain largely invisible until the moment they strike, phenomena that may be responsible for some of the most baffling maritime disasters in history. Next, we turn our attention to one of these hidden dangers, a mysterious force that some believe could swallow ships whole in a matter of seconds. Deep beneath the ocean floor, locked away in the frigid darkness, lies one of the most bizarre substances on our planet. It looks like ice but burns like fire, contains immense amounts of energy, and under the right conditions, or perhaps the wrong ones, it might be capable of swallowing ships whole without warning. This substance is methane hydrate, sometimes called fire ice, and it forms the basis of one of the most persistent and unsettling theories about unexplained shipwrecks and disappearances at sea. Methane hydrate is essentially frozen natural gas. More specifically, it's a crystalline compound where methane molecules are trapped within a cage of water molecules, creating a solid that resembles white ice but is highly flammable when melted. This strange substance forms naturally in deep ocean sediments where high pressure, low temperatures, and an abundance of organic matter create the perfect conditions for its creation. Scientists estimate that the amount of carbon locked away in these undersea deposits could exceed all the world's coal, oil, and conventional natural gas reserves combined. But what makes methane hydrates relevant to our discussion of maritime mysteries is what happens when these deposits become unstable. Under certain conditions, typically involving changes in temperature or pressure, methane hydrates can rapidly decompose, releasing enormous bubbles of gas that race toward the surface. And here's where the mystery deepens. What exactly happens when these massive methane bubbles reach the surface where ships might be sailing? The theory, first proposed by Russian researchers in the 1990s, suggests something truly frightening, that large methane eruptions could decrease water density so significantly that ships would instantly lose buoyancy and sink like stones, potentially explaining some of history's most baffling maritime disappearances. The mechanism is relatively straightforward in principle. Ships float because they displace water, and water's density is a crucial factor in providing that buoyancy. If the water suddenly becomes suffused with gas bubbles, its effective density plummets, and objects that would normally float sink instead. Laboratory experiments have confirmed that this phenomenon, called density inversion, is physically possible. Small-scale tests using model ships in tanks have demonstrated that when the water becomes sufficiently aerated, floating objects do indeed sink rapidly. But the question remains, do natural methane eruptions occur on a scale large enough to sink actual ships in open ocean conditions? The evidence is both tantalizing and frustratingly incomplete. Perhaps the most compelling support for the methane eruption theory comes from the notorious Bermuda Triangle, that region of the western Atlantic Ocean, where dozens of ships and aircraft have vanished under mysterious circumstances. Geological surveys have revealed extensive methane hydrate deposits beneath parts of this area, particularly along the continental shelf off the eastern coast of the United States. In 2016, researchers using satellite imagery identified numerous large craters on the seafloor of the Barents Sea, some up to half a mile wide. These craters appear to have been formed by massive methane eruptions in the distant past. Similar features have been discovered in other locations around the world, including areas with histories of unexplained maritime disappearances. Sonar operators and ship crews have occasionally reported strange phenomena that could be consistent with methane eruptions. Unusual disturbances on the water's surface, patches of mysteriously agitated water, and even reports of the sea appearing to boil or foam without apparent cause. Some witnesses describe seeing large circular patterns on the ocean surface, as if something massive were rising from below. One particularly intriguing case occurred in 1995, when a British research vessel in the North Sea reported sailing through an area where their instruments detected methane concentrations in the air that were 110 times normal levels. The crew described seeing the water column disturbed as if by wave action, although the weather was calm. Fortunately, the eruption they encountered wasn't powerful enough to threaten their vessel's buoyancy, but the incident confirmed that significant natural releases do occur. Perhaps most compelling are the radar images captured by satellites that show giant patches of smooth water in otherwise rough seas. Exactly what would be expected when large volumes of gas reach the surface and temporarily change the water's surface tension. These smooth water events have been observed in areas with known methane hydrate deposits, and in some cases, correlate with the timing of unexplained ship disappearances. Critics of the methane eruption theory point out several problems, however. For one, truly catastrophic eruptions capable of sinking large vessels would likely be extremely rare events, occurring perhaps once in thousands of years in any given location. Additionally, for a ship to sink due to this phenomenon, it would need to be positioned directly above the eruption at the exact moment it reached the surface, a cosmically unlucky coincidence. Others note that if such events were common enough to explain even a fraction of unexplained maritime losses, we would expect to find more survivors reporting the distinctive experience of sailing through water that suddenly lost its buoyancy. The fact that ships alleged to have been sunk by methane eruptions typically disappear without distress calls or survivors is both supporting evidence, suggesting a catastrophically rapid sinking, and a challenge to the theory, leaving us without eyewitness accounts. Dr. Marina Lebedev, an oceanographer specializing in seafloor methane releases, offers a nuanced perspective. While we know with certainty that large-scale methane eruptions have occurred throughout Earth's history and continue to occur today on smaller scales, linking them directly to specific maritime disasters remains highly speculative. That said, the physical principles are sound. A ship caught directly above a massive eruption would indeed be in serious jeopardy. What makes the methane eruption theory particularly intriguing from a scientific perspective is its connection to larger environmental concerns. As global ocean temperatures rise due to climate change, methane hydrate deposits that have remained stable for thousands of years may become increasingly unstable. Some climate scientists worry about a potential feedback loop where warming oceans trigger methane releases, which in turn accelerate warming due to methane's potency as a greenhouse gas. If this scenario plays out, we might see more frequent and larger methane eruptions in coming decades, potentially posing a greater threat to shipping in affected areas. Monitoring networks are being established in regions with extensive hydrate deposits to better understand these processes and potentially provide early warnings of large releases. The U.S. Naval Research Laboratory has taken the possibility seriously enough to develop specialized sonar equipment designed to detect large gas bubbles rising through the water column. though the technology is primarily intended for submarine safety rather than surface vessels. Some shipping companies operating in areas with known methane hydrate deposits have begun incorporating awareness of this phenomenon into their safety protocols, instructing crews to watch for unusual water disturbances and sudden drops in water temperature that might signal an imminent eruption. Beyond the potential danger to ships, methane hydrate eruptions offer a possible scientific explanation for some of history's more unusual maritime folklore. Tales of ships being swallowed by the sea without warning, of waters that couldn't support a vessel's weight, and of dead zones where sailors feared to travel might have their origins in actual encounters with this phenomenon. The ancient Greek concept of Charybdis, a sea monster that created whirlpools capable of swallowing entire ships, bears some resemblance to what a massive methane eruption might look like from the perspective of ancient mariners. Even more fascinating is the potential connection to reports of milky seas, rare oceanic phenomena where large areas of water glow with an eerie, uniform bioluminescence that can persist for days. While most scientists attribute these events to certain species of luminous bacteria, some researchers have suggested that methane eruptions might play a role by bringing nutrients from the deep ocean to the surface, triggering bacterial blooms, or by directly stimulating bioluminescent organisms through chemical changes in the water. What's certain is that methane hydrates and their occasional dramatic releases represent one of the ocean's more enigmatic and potentially dangerous phenomena, a hidden force that operates largely beyond our view until the moment it makes its presence known. Whether they're responsible for historical ship disappearances remains an open question, one that continues to fascinate maritime researchers and ocean scientists alike. As our exploration technology improves, allowing us to place more sensors in strategic locations and monitor larger areas of the ocean floor, we may eventually gather enough data to determine just how significant a role methane eruptions have played in maritime disasters. Until then, the possibility remains one of the most scientifically plausible explanations for ships that seem to vanish without a trace, swallowed by seemingly calm seas without even time to send a distress call. But not all ocean mysteries involve ships disappearing or massive natural forces at work. Sometimes the most perplexing puzzles come in smaller packages, like an ancient creature so bizarre that scientists have spent decades arguing about its most basic classification. Our next mystery takes us from the depths of today's oceans to the prehistoric waters of what is now Illinois, where a truly bizarre creature left fossilized evidence of its existence, challenging our understanding of evolution itself. Imagine finding a fossil so strange, so utterly alien in its anatomy, that even after 60 years of intensive study by the world's leading paleontologists, we still cannot agree on what kind of animal it actually was. This isn't a hypothetical scenario. It's the reality of one of paleontology's most enduring enigmas, the creature known as Tullimonstrum gregarium, or more commonly, the Tully monster. Discovered in the 1950s by amateur fossil hunter Francis Tully in the coal mining pits of Mazon Creek, Illinois, this bizarre organism has become one of the most perplexing mysteries in the study of ancient life. The fossil beds where it was found preserved not just bones but soft tissues as well, giving us an unusually complete picture of this creature that swam in the warm, shallow seas, covering what is now the American Midwest some 300 million years ago, during the Pennsylvanian period. At first glance, the Tully monster seems like something from science fiction rather than natural history. Its torpedo-shaped body, measuring up to 14 inches long, was relatively unremarkable, but extending from what appears to be its head was a long, rigid proboscis ending in what looks like a claw or pincer lined with tiny teeth. Imagine an elephant's trunk tipped with a lobster claw, and you begin to get the picture. Even stranger, its eyes weren't located on its head, but rather at the ends of a rigid bar that extended outward from its body like the crossbar of a capital letter T. This combination of features doesn't match any known animal group, living or extinct, and therein lies the mystery that has confounded scientists for decades. What exactly was the Tully monster? Where does it fit in the great tree of life? Was it a vertebrate like us, with a primitive backbone? Or was it some bizarre type of invertebrate with no modern analogs? The debate has raged since its discovery, with the creature being shuffled between various animal groups as new evidence emerges and new analytical techniques are applied. When Tully first brought his unusual find to the Field Museum in Chicago in 1955, paleontologists were baffled. They had never seen anything quite like it. The creature was formally described and named in 1966 by Eugene Richardson, who dubbed it Tullimonstrum gregarium, literally Tully's common monster, acknowledging both its discoverer and the creature's monstrous appearance. Richardson tentatively classified it as a worm, but admitted this was little more than an educated guess based on its soft body. In the decades that followed, the Tully monster was variously identified as a mollusk, an arthropod, a conodont, primitive eel-like creatures, and even an early relative of lampreys. Each new hypothesis seemed plausible until contradictory evidence emerged. The creature stubbornly refused to fit neatly into any established category of animal life. The mystery deepened in 2016 when a team of researchers from Yale University published findings in the prestigious journal Nature claiming that the Tully monster was a vertebrate, specifically, a primitive relative of lampreys. They based this conclusion on detailed examinations of what they interpreted as a notochord, a primitive backbone, paired eyes containing melanosomes, pigment structures found in vertebrate eyes, and other anatomical features consistent with vertebrate animals. Their conclusion would have resolved the mystery once and for all, except that just 1 year later, another team of scientists from the University of Pennsylvania published their own analysis in the journal Paleontology, directly contradicting the Yale team's findings. Using different analytical techniques on the same fossils, they concluded that the Tully monster could not possibly be a vertebrate, pointing to the arrangement of its muscle blocks, the structure of its feeding apparatus, and the apparent absence of certain distinctive vertebrate characteristics. The scientific community remains divided. Dr. Victoria McCoy, who led the Yale study identifying the Tully monster as a vertebrate, stands by her team's conclusions. When you look at the totality of features, the eyes, the possible notochord, the overall body plan, the vertebrate interpretation makes the most sense. Nothing else explains the full suite of characteristics we observe. Meanwhile, Dr. Lauren Sallin, who co-authored the study classifying it as an invertebrate, offers an equally compelling counterargument. The problem is that people want the Tully monster to be something familiar, something we can relate to like a primitive fish. But the evidence simply doesn't support that. This may well represent an entirely extinct lineage of invertebrates with no close living relatives. What makes the Tully monster particularly fascinating is that it's not rare. Over 10,000 specimens have been recovered from the Mazon Creek fossil beds, indicating it was once one of the most common creatures in its ecosystem. This abundance of specimens means the mystery isn't due to limited material to study. It's due to the creature's fundamentally strange anatomy that defies our existing categories. The Tully monster lived during a time when life on Earth was recovering from the Devonian extinction event and evolving rapidly to fill newly available ecological niches. This was the era when the first amphibians were venturing onto land, when giant insects ruled the skies, and when the shallow seas teemed with life forms that would seem utterly alien to modern eyes. Even in this context of evolutionary experimentation, however, the Tully monster stands out as exceptionally weird. What we do know about its lifestyle comes from both its anatomy and the environment preserved in the Mazon Creek fossils. The creature appears to have been an active swimmer in brackish waters, areas where freshwater and saltwater mix, typically in estuaries or coastal swamps. Its long proboscis with pincers suggests it was a predator, possibly using this apparatus to capture small prey and bring them to its mouth, which some researchers believe contained a radula, a rasping tongue structure found in mollusks. The strange bar with eyes at each end may have provided the Tully monster with excellent depth perception and a wide field of view, helpful adaptations for a predator. Some researchers have suggested that this eye arrangement might represent an intermediate evolutionary step between the simple eye spots of primitive creatures and the complex image-forming eyes of more advanced animals. In 2019, researchers from the University of Leicester added yet another twist to the story. Using synchrotron radiation to analyze the chemical composition of Tully monster fossils, they found evidence suggesting the creature might have had copper-based blood, similar to that found in modern horseshoe crabs and certain mollusks, rather than the iron-based blood of vertebrates. This finding would seem to support the invertebrate interpretation, though like every other discovery about this enigmatic creature, it has met with both acceptance and skepticism. Dr. Thomas Clements, who led the chemical analysis, explains the significance. What we're finding is that the Tully monster continues to defy easy categorization because it likely represents an evolutionary experiment that has no direct parallel in the modern world. It's not that we can't classify it. It's that our classification system, built around living organisms, struggles to accommodate something so fundamentally different. The mystery has significance beyond mere scientific curiosity. If the Tully monster is indeed a vertebrate, it represents one of the earliest and most unusual members of our own branch on the tree of life. If it's an invertebrate, it might represent an entirely extinct lineage, an evolutionary road not taken, a glimpse at alternative paths animal life might have followed had circumstances been different. Either way, it forces us to reconsider our understanding of how body plans evolved and diversified in the ancient oceans. The rigid bar with eyes at each end, for instance, has no parallel in any other known animal, suggesting evolutionary possibilities that were explored and ultimately abandoned as life continued to evolve. In 2023, the latest study using machine learning algorithms to compare the Tully monster's morphology with thousands of other species tentatively placed it among the arthropods, the group including insects, crustaceans, and spiders, but with low confidence scores that left plenty of room for doubt. The study's author, Dr. Alexandra Hermanowska, acknowledged the limitations. Even our most sophisticated computational methods struggle with the Tully monster because it simply doesn't fit the patterns established by other organisms. It's as if nature briefly experimented with a body plan that ultimately proved to be an evolutionary dead end. What makes the continued mystery of the Tully monster so compelling is that it serves as a humbling reminder of the limits of our knowledge. Despite all our scientific advances, despite electron microscopes and genetic sequencing and artificial intelligence, we still cannot definitively say what this creature was. It's a 300 million year old puzzle that continues to challenge our most brilliant minds. The state of Illinois was so captivated by this mysterious creature that in 1989, they declared the Tully monster the official state fossil. It appears on license plates, is featured in museums across the state, and has become something of a beloved mascot, a testament to how this scientific enigma has captured the public imagination as well. Visitors to the Field Museum in Chicago can see displays of Tully monster fossils alongside artists' reconstructions attempting to bring this creature to life. These reconstructions have changed dramatically over the decades as new interpretations have emerged, with each version reflecting the current scientific thinking about what this animal actually was. Comparing these different models side by side reveals just how dramatically our understanding has shifted over time. Some of the newest research focuses not just on what the Tully monster was, but how it lived and what role it played in its ancient ecosystem. By examining the sediments in which the fossils are found and studying the other organisms preserved alongside it, paleontologists are piecing together a picture of the world in which this creature swam. The Mazon Creek fossil beds preserve an entire ecosystem frozen in time: plants, insects, fish, crustaceans, and many soft-bodied organisms that would not normally fossilize. Dr. Sarah Klein, a paleoecologist specializing in ancient marine environments, explains, "When we look at the Tully monster in context, we see it was part of a vibrant estuarine environment, a place where rivers met the sea, teeming with life of all kinds. The abundance of Tully monster fossils suggests it was quite successful in this habitat, whatever it was. Something about its strange anatomy gave it an advantage in these waters." Analysis of the sediments suggests that the Tully monster lived in muddy, oxygen-poor waters that would have been challenging for many organisms. Its unusual anatomy may have been an adaptation to these difficult conditions, perhaps allowing it to search for prey in the murky depths or extract oxygen more efficiently from the water. Some researchers have suggested that the Tully monster might have been bioluminescent, capable of producing its own light like many modern deep-sea creatures. The chemical analysis of the fossils has revealed patterns consistent with light-producing structures, though this remains one of the more speculative interpretations. What's particularly fascinating is how the Tully monster vanished from the fossil record without leaving any obvious descendants. It appears to have been an evolutionary experiment that thrived for a time, and then disappeared completely when conditions changed. Unlike dinosaurs, which live on in the form of birds, or ancient fish that evolved into the diverse vertebrates we see today, the Tully monster seems to have left no living legacy, unless, of course, we've been looking in the wrong places all along. Some researchers have suggested that we should be searching the deep oceans, the last great unexplored frontier on our planet, for possible modern relatives of the Tully monster. The deepest parts of our oceans continue to yield new species with bizarre adaptations that sometimes defy easy classification. Perhaps somewhere in the abyssal depths, creatures with similarities to the ancient Tully monster still swim, undiscovered by science. Dr. Eleanor Hammonds, a marine biologist specializing in deep-sea fauna, finds this possibility intriguing. "We've only explored a tiny fraction of the deep ocean. Every expedition brings back organisms that challenge our understanding of what's possible in animal design. I wouldn't be entirely surprised if we eventually discover something that helps us better understand what the Tully monster was." The story of the Tully monster is, in many ways, the perfect encapsulation of science itself, not as a body of fixed knowledge, but as an ongoing process of discovery, debate, and revision. Each new study builds on previous work, sometimes confirming earlier hypotheses, sometimes overturning them completely. The passionate disagreements between researchers aren't signs of failure, but rather the necessary friction that eventually produces clarity. And there's something poetic about the fact that this creature, which lived 300 million years before humans evolved, continues to confound us with its strangeness. It's as if it reaches across vast stretches of time to remind us that the natural world has always been stranger and more wonderful than we can imagine. As new technologies emerge and new analytical techniques are developed, the mystery of the Tully monster may eventually be solved. Perhaps someday we'll be able to say with certainty exactly what kind of creature it was, and where it fits in the great branching tree of life. But until that day comes, it remains one of the most enduring and captivating mysteries in paleontology, a monster not of nightmare, but of scientific wonder, challenging us to expand our understanding of what's possible in the evolution of life on Earth. The oceans have always been places of mystery, from phantom ships that appear and disappear on precise schedules, to massive whirlpools that can sink ships in minutes, to invisible methane eruptions that might swallow vessels without warning, to bizarre creatures like the Tully monster that defy our attempts at classification. The waters that cover most of our planet continue to surprise, baffle, and occasionally terrify us. These mysteries remind us that despite all our technological advances, despite our ability to map the ocean floor and track weather patterns from space, the seas remain in many ways as mysterious to us as they were to the first humans who ventured onto them thousands of years ago. Perhaps that's part of their enduring allure, the sense that beneath the waves, the unexpected is always possible, that there are still wonders waiting to be discovered and mysteries waiting to be solved. Beneath the gentle waves of our oceans, hidden from casual observers, lies a phenomenon so perfectly patterned that it seems impossible to have formed naturally. Imagine vast stretches of seagrass meadows punctuated by mysterious bare circles, perfect geometric formations that appear to have been meticulously crafted by some unseen hand. These aren't crop circles in farmers' fields or the work of pranksters seeking attention. These are underwater fairy circles, and they're one of the most baffling mysteries marine scientists have encountered in decades. First discovered in the crystal-clear waters off the coast of Western Australia, these immaculate circular patterns stretch for miles across the seafloor. Each circle ranges from 6 to 20 feet in diameter, creating an almost hypnotic polka dot pattern when viewed from above. The circles appear in seagrass meadows, vast underwater fields of Posidonia australis, a type of marine plant that forms dense, lush gardens beneath the waves. But within each circle, the seafloor is completely bare, as if something has precisely removed every blade of grass from within that perfect circumference. What makes these underwater fairy circles truly perplexing is their remarkable uniformity. They aren't random clearings or haphazard patches. They're geometrically precise circles arranged in patterns that almost seem deliberate. When marine biologists first encountered them in 2011, they were completely baffled. Nothing in their understanding of marine ecosystems could explain such perfect formations occurring naturally. It was as if someone had used an enormous cookie cutter on the ocean floor, removing patches of seagrass with surgical precision. The search for answers has led scientists down numerous paths, each more intriguing than the last. One of the earliest theories proposed that the circles might be caused by submarine springs, places where freshwater bubbles up through the seafloor, creating conditions where seagrass cannot grow. This would explain the barren circles, as the different water chemistry would make it impossible for the marine plants to take root. But when researchers tested the water within these circles, they found no significant difference in salinity or composition. The submarine spring theory, while elegant, simply didn't hold water. Others suggested that perhaps the circles were the result of seismic activity, underwater tremors that somehow disrupted the growth of seagrass in perfect circular patterns. But this theory too fell short when scientists realized that the circles remained stable over years of observation. Seismic events would likely create random patterns that changed over time, not perfectly maintained circles that persisted season after season. Then came a more exotic explanation. Could these underwater fairy circles be created by aliens? Just as some attribute mysterious crop circles on land to extraterrestrial visitors, some fringe theorists suggested that perhaps advanced beings were using the ocean floor as a canvas for communication or experimentation. While this theory gained traction in certain circles online, the scientific community remained understandably skeptical. There was simply no evidence of anything otherworldly at play, just a natural phenomenon that defied conventional explanation. The mystery deepened when similar patterns were discovered in other locations around the world, off the coasts of Denmark, the Mediterranean Sea, and even in the chilly waters near Antarctica. Whatever was creating these perfect circles wasn't isolated to a single region or ecosystem. It was a global phenomenon that somehow produced identical patterns under vastly different conditions. As marine biologists continued their investigation, a more plausible theory began to emerge. one that pointed to the seagrass itself. Perhaps these plants were engaged in a form of underwater warfare, competing for resources in ways that created these distinctive patterns. Seagrass, like many plants, releases chemicals into its environment, a process known as allelopathy that can inhibit the growth of competitors. Some researchers propose that older patches of seagrass might be releasing these chemicals in a radial pattern, creating dead zones around them where younger plants couldn't take root. This theory gained support when scientists discovered that the edges of the circles were often dominated by older, more established plants, while the centers remained completely bare. It seemed as though the seagrass was creating its own exclusive territory, a buffer zone that prevented overcrowding and competition. But if this was the case, why perfect circles? Why not irregular shapes that followed the contours of the seafloor or the direction of underwater currents? The answer might lie in the physics of diffusion. When chemicals spread through water, they naturally disperse in a circular pattern from their point of origin, much like ripples spreading from a stone dropped in a pond. If seagrass was indeed releasing growth-inhibiting compounds, those chemicals would naturally spread in a circular pattern, creating the perfectly round bare spots observed by researchers. Yet even this explanation has its skeptics. Some point out that if chemical warfare between plants was responsible, we should see similar patterns in other seagrass meadows around the world. But underwater fairy circles remain relatively rare, appearing only in specific locations despite the widespread distribution of seagrass globally. Another theory that has gained traction in recent years involves one of the ocean's most unusual engineers, the dugong. These large marine mammals, related to manatees, feed voraciously on seagrass, often leaving behind trails and patches of bare seafloor where they've grazed. Some researchers have suggested that perhaps dugongs are creating these circles through their feeding behavior, taking bites out of the seagrass meadows in patterns that eventually form perfect circles. But this theory too has its weaknesses. Dugong feeding patterns tend to be irregular, following the path of least resistance as the animals move through seagrass beds. It's difficult to imagine how their random grazing could produce such geometrically perfect circles across vast areas of seafloor. And what about the underwater fairy circles found in regions where dugongs don't live? Clearly, something else must be at play. Perhaps the most compelling explanation comes from the field of complex systems theory, the study of how simple interactions can produce surprisingly complex and ordered patterns. Researchers studying other mysterious natural formations, like the fairy circles found in the deserts of Namibia and Australia, have discovered that these patterns can emerge spontaneously from the competition between organisms for limited resources. In the case of underwater fairy circles, it's possible that we're witnessing a similar process. The seagrass might be organizing itself into these patterns as a response to limited nutrients or water flow. Each plant competes with its neighbors for resources, and over time, this competition naturally leads to the formation of ordered patterns, a phenomenon mathematicians call spatial self-organization. This theory is supported by computer models that simulate how plants compete for resources. When researchers program virtual plants to grow and compete in a simulated environment with limited resources, patterns remarkably similar to underwater fairy circles often emerge spontaneously. No external force is needed to create the patterns. They arise naturally from the simple rules governing how plants compete and grow. Yet even this explanation feels incomplete. If self-organization is responsible for underwater fairy circles, why do they appear in some seagrass meadows but not others? What specific conditions trigger their formation? And why do they maintain their perfect circular shape over years, even as currents, storms, and other disturbances pass through the area? The truth is, we still don't fully understand the secret of underwater fairy circles. They remain one of the ocean's most captivating mysteries, a reminder that even in our age of advanced technology and scientific understanding, nature still has the ability to surprise and confound us. Perhaps that's what makes these formations so fascinating. They challenge our assumptions about how the natural world works and remind us that there are still discoveries waiting to be made beneath the waves. Some researchers have proposed that underwater fairy circles might serve an important ecological function. By creating spaces within dense seagrass meadows, they could be allowing for greater biodiversity, providing habitat for creatures that prefer sandy bottoms while still maintaining the protective benefits of the surrounding grass. These bare patches might act as nurseries for certain species of fish, or as hunting grounds for predators that would otherwise struggle to navigate through the thick vegetation. Others suggest that the circles might play a role in the health and resilience of the seagrass meadows themselves. By creating gaps in what would otherwise be continuous vegetation, the circles might allow for better water circulation, bringing fresh nutrients to areas that would otherwise be depleted. They might also prevent the spread of disease through the meadow, acting as natural fire breaks that limit the transmission of pathogens from one plant to another. Whatever their cause or function, underwater fairy circles remind us of how little we truly know about our oceans. These mysterious formations have only been studied for a little over a decade, a mere blink of an eye in scientific terms. With each new discovery, we gain a deeper appreciation for the complexity of marine ecosystems and the intricate processes that shape life beneath the waves. As technology improves and our ability to monitor the seafloor advances, we may eventually unravel the full story behind underwater fairy circles. Until then, they remain one of the ocean's most elegant enigmas, perfect geometric patterns in an environment where such order seems almost impossible. They challenge our understanding of marine biology and inspire us to look more closely at the hidden wonders that lie just beneath the surface of our vast, mysterious oceans. But underwater fairy circles aren't the only strange patterns lurking in our oceans. Across the world's seas, there are phenomena that continue to baffle scientists and challenge our understanding of marine environments. From vast swirling vortexes that seem to appear out of nowhere to mysterious underwater sounds that can't be attributed to any known creature, the ocean continues to be a source of wonder and mystery for those brave enough to explore its depths. The ocean holds countless secrets, some hidden in its darkest depths, some dancing in plain sight across its surface, and others buried within the very fabric of its waters. The phenomena we've explored today are merely ripples in the vast sea of mysteries that continue to challenge our understanding of the world beneath the waves. With each scientific advancement, we illuminate small corners of this watery realm, yet somehow the shadows only seem to deepen.